Welcome everyone, this is Michael Gibbs. I hope you can all hear me. If somebody could just let me know that you hear me by maybe typing Cloud Architect, or I can hear you in the chat box so I know that you're there. Hopefully you can hear me, and today we are going to have a lot of fun. And we're going to be focusing on some networking fundamentals, but you know it's me. And you know I've been working in networking since well over 25 years. And because I love networking, even if we start talking about something as fundamental, for example, as subnetting, we're going to talk about it in a way that's going to build your cloud architect career. So sure, we'll talk about subnetting. Sure, we'll talk about supernetting. Sure, we'll talk about route aggregation. We'll talk about how you can actually plan your system. So we're going to have fun, and it's going to be highly interactive, and it's not just going to be basic subnetting. Our goal is to build you guys extraordinarily good cloud computing careers. So thrilled that you guys are here. I see some people that I know, like Christian and Ran and Shapur. And Adele, wonderful, and Ran, wonderful. So happy to have you here, and Jay, and Femi, and Alonzo, Theo, and Alex. Welcome. For those of you that are not one of our students, welcome too. We're still thrilled and super excited to hear you. So let me give you guys all a bit of a flow idea so you know what we're going to talk about today. But before we begin, you really need to know the background of who's teaching the course. So it's a networking course, so I'll give you a little bit about my networking background. I've been in networking for as long as I can count. In fact, my CCIE number is 7417. Now, if you know anything about Cisco and CCIEs, they were kind of geeky people. I was one of them. They started counting at 1028 instead of 0 because it was 2 to the 10th. So my 7417 number had basically encompassed all 3 million people prior to me that had worked toward this exam. And I was the 6,400 guy to basically pass it. So that's how long I've been in networking, that many years. And during these years, I've worked for some of the world's largest internet service providers. I've worked for Cisco. I've consulted to internet service providers off the world. I set up the voice, data, and video projects that are spread throughout the world. I've designed the systems for cloud providers. I've designed the systems for pretty much everybody. So I've got about 25 years which is at least 50,000 hours of experience in networking, and well over 10,000 hours in just BGP, and another $10,000 in PIM. So I've been in the networking world forever. These days, I teach cloud computing. Me and many of the networking people that I've worked with over the last 2 decades all moved to the cloud. Why do we move to the cloud? Because the cloud's just the next evolution of the network and the data center. So I welcome you all to the cloud. It is a wonderful place. It is the future, and there's lots of career opportunity here. So in order to be an architect, which is what we teach, you've got to have the architecture skills. What are architecture skills? Design skills, communication skills. And what is the cloud? It's no more than just a virtual network and a data center. So why are we so focused on it? Because we want you to be great. So we're going to teach you the network. And today, the most fundamental component of the network is the IP addressing scheme. Your IP addressing scheme will change everything, and we're going to do some fun IP addressing schemes today. And we're going to bring it into there. We're going to subnet, we're going to supernet or route aggregate. We're going to create a routing environment with summarized routes. We're going to have a big IP party for the next 4 hours. So welcome. You're all excited to be here. Type Cloud Architect in the chat box. And if you're happy to be here, please leave a like or a comment. It signals the algorithm that we're doing good things. So let's begin. Let's walk through the exact format of the day. We're going to begin with what is subnetting. After subnetting, we're going to talk about what are classful IP addresses. Then we're going to talk about what goes into subnetting, and then we're going to subnet. And this is going to get fun. Nick, thrilled to happy to be here. Arun, super happy, hand of God, so thrilled you're here. So then when we teach you how to subnet, we're going to go in the opposite direction. Subnetting goes one way, but there's supernetting, which goes the other way. And when you're dealing with CIDR, you have to do both. So we're going to have fun. We're going to go down and we're going to go up. Then after we do that, we're going to do lots of examples. Lots of examples because we're building cloud architects here. And then we'll talk about planning your subnets and optimizing your subnets. And then after we talk about planning and optimize your subnets, we're going to do some cool designs. And I'm willing to stick around and whiteboard some scenarios and answer lots of questions. Not super time constrained today. I've allocated 4 hours. If you guys are having so much fun, you want a little more, you got it. All we want to do is make sure you have a wonderful cloud architect training experience so you can have the best cloud architect career. So first and foremost, what is subnetting? I'm going to make it real simple. All subnetting is you take an IP network and you break it into something smaller. That's it. And we're going to show you what that actually means, and we're going to show you why. But basically, you're going to take one network and break it into smaller little networks. That's it. Now, why? Why do we have to do this? To conserve IP addresses. And I'm going to walk you through an example in a minute, but we have no issue. We have to conserve IP addresses because there's not enough of them. Now, I want you to think like a network engineer for 5 minutes. Let's say you've got a router with 15 different interfaces. One goes to one direction, one goes to another direction, one goes to another direction. Each interface needs to be on a separate network. So if we didn't subnet, we'd have a massive problem. I'm going to show you what that would be in a second. So without subnetting, basically we would have run out of IP addresses so many years ago. So let me walk you through an example, and this is not the official symbol for a router. This is someone on my team that's a graphic artist that I ask him to basically make things light and fun so we can all learn. Look at these addresses that are used here. If we were using a classful network without subnetting, and we're going to talk about what that means. Let's say we have the 2.0.0/8 and the 1.0.0/8 and the 3.0/8 and the 4.0.0/8. What's going on here? Well, each interface needs to be on a separate subnet. And if we used these 4 networks just for 4 interfaces on this router, we'd be using 64 million IP addresses. And I'll show you why. But this would be 64 million IP addresses that are literally wasted on one router and nothing else in the world. Why? Because it's a /8, and I'm going to show you the math. We're going to back into the number of hosts, number of networks. We're going to get there. Understand that if we didn't do subnetting here, we'd basically be wasting 16 million IP addresses per port. Now let's go break into something where I did some subnetting here, for example. I broke those network downs into something that matters. Guess what? How many addresses I'm using now? 4 for the top, 4 for the left, or the right, 4 on the bottom, and 4 to the left. So realistically speaking here, just by looking at that, I've saved 64 million addresses minus 16. That's why organizations subnet, to use their IP addresses properly. Using 30 or 16 versus 64 million. That's the reason. So now, before we even get into this, we've got to get into the concept of classful addresses, especially when we start talking about IP classful, CIDR, subnetting, supernetting. Now you're getting into some really complicated stuff. So we're going to walk through some of these things from different angles, and I'm going to show you what they look like, and then we're going to have fun with it. So let's go to this particular situation here. Originally speaking, when the IETF came up with the concept of IP addressing, and people were using this many years ago, there weren't that many people on the network. In fact, when the internet came around, it was a couple of universities and DARPA, and it was an experimental university/military research project. There were a couple of remote locations, and they looked at it and said, this is great. And no one expected the internet to do what it did. No one expected it to blow up. No one expected, everybody to have an iPhone or a Samsung phone or whatever, have 3 phones in a house that all need their own unique IP addresses, multiple computers in a house, web servers everywhere, app servers everywhere, Internet of Things devices, RFID tags. Nobody planned on this. What did we all think was going to happen? You put 10 devices in a network, so nobody thought about it. So the IPv4 address is a 32-bit address, which is a whole lot of addresses. Just not enough for today's world. Now, initially speaking, they came up with address classes. There was a class A, a class B, a class C, a class D, and then there was this experimental class which nobody's ever done anything with. So what is class A addresses? These are the /8s that you see. Now, most specifically, a Class A address begins with a 1, like 1.0.0.0 or 1.0.0.1, and goes all the way to 126.255.255.255.255. That's the limit. That's the broadcast address for that subnet. So these are big, these Class A addresses. Lots of addresses. You want to know how many addresses you have in one of these subnets? You're going to go 2 to the 24th power minus 2. And we're going to show you in the next slide when we get into some subnet stuff. We're going to have lots of fun with this stuff. But when we get into this subnet stuff, we're going to be calculating the actual addresses that are there. So you'll see that there's, basically speaking, 16 million addresses with a Class A. Now, as I previously showed you, if you actually applied a Class A to anything, it would use up all 16 million addresses. So you've got to subnet this down if you want to do something. I also showed you how I could use 64 million addresses without subnetting versus 16 addresses with subnetting. Wow, 16 million, 16. What, a million times more? That's how efficient subnetting can get you, and that's why we have to do this. Now, the next concept of the Class B, which is a /16, began with 128 and went to 191. So the private IP address space, like the 172.16.0.0, Class B address, Class B private address, but a Class B address. Now it's got a 16-bit subnet mask. So in a minute, we're going to talk about the host mask, the subnet mask, bits and bytes, and all of that. But Class A, basically 1 to 126. Class B, 128 to 199. Class C addresses, which by nature are /24. Which give you 253 addresses. Well, technically 254, but that's neither here nor there. And that's 192 to 223. Now, when we start getting into Class D addresses, this is for IP multicast. There's no subnet masks that we're going to be dealing with. And Class C are experimental drugs, and they're not there. So now let's look at this from another angle. A Class A network has 8 network bits and 8 host bits. What do I mean by that? 8 network bits and 8 host bits. So we'll work through this in a second. Now a Class B has 16 network bits and 16 host bits, while a Class C has 24 network bits and host bits. So let's draw this out a little bit for you. We'll do some interactivity while we're having fun here. So for example, let's say we have an IP address that's network bits with a /8. So what the address is going to look like is network, and then here's the host bits. It's going to be a dot. You're going to have 1, 1, 1, 1, 1. Hold on, let's say we can be ones or zeros. So we're just going to take ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's what a Class A looks like. These ones or zeros are host bits. The network piece is the network. So let's look at how we could calculate how many come here. And we're going to get through this. We're going to do it a lot of ways. But one host bit, so a /20, one host bit means one host. 2 host bits is something different. 4 host bits is something different. So this is binary. When you're dealing with an IP address, and you're realistically speaking, let's just make this all ones for right now. You're dealing with a 32-bit address. So the total number of IP addresses in circulation is going to be 2 to the 32nd minus 2. So someone in this audience, tell me how many IPv4 addresses actually exist. Well, we're going to potentially exist if we didn't have the Class Ds or multiclass and the Class Es, which we don't use. 2 to the 32nd minus 2. That's what you're going to need to know. So we can work it out together to some of this. So for example, 2 to the 1st equals 2, or 2 to the 2nd equals 4, 2 to the 3rd equals 8, 2 to the 4th equals 16, 2 to the 5th equals 32, 2 to the 6th equals 64, 2 to the 7th equals 128. So that's basically how you're calculating these things to determine things. So Arun, 65536 is unfortunately not the total. That's the number of addresses available for Class B. 2 to the 16th minus 2 will get you to to 65536. You're dealing with 2 to the 32nd power minus 2. So you can take a scientific calculator and do 2x32. That'll give you an answer minus 2, and then you'll see exactly how many hosts you're going to get there. Nick Lowe, 4.2 billion. That sounds about right. So there's 4.2 billion IPv4 addresses. Now let's think about that. 7 billion people in the world, we could almost make it, especially with private IP addresses, no big deal. What about these iPhones? What about people with mobile phones? They need an IP address. 7 billion people in the world. How many mobile phones? Probably 7 billion. Okay, so poof, that's a problem. How many servers in the world? Billions. Okay, that's a problem. How many people have a computer in their house? Which means an internet connection, which means a public IP address. Okay, that's a problem. So now you see why we have to subnet these things down. We need to use these addresses more efficiently. So with a /8, you've got 16 million usable addresses, but every time you put an address on an interface, it's all used up. And you could, what if you said, what if we plug them all in the same VLAN and a switch? 65,000 hosts in a VLAN. Would it work from an IP addressing perspective? Absolutely sure, no problem. Well, won't it work in a reality perspective? Because once you get above, say, 250 to 300 hosts, the hosts do broadcast. They say, hey, you there? ARP, who has this MAC address? I'm a printer, I'm here, do you know it? NetBIOS, NetBUI, these systems they send broadcasts constantly. And what happens is they fill up the links. You've got to constrain them. And the only way you constrain them is with subnetting and by placing them on additional interfaces. So that's why we do these things. And that's why we focus so hard on breaking them down. Class A, 8 network bits. And this, so what does a Class A look like? It looks like something as follows, 255, because that's the only number of network bits we have, .0.0.0. That's a Class A subnet mask. Now a Class B has 16 bits of subnet mask. So it's going to look like that. And a Class C has 24 bits of subnet mask. Okay, so how do you count the subnet bits? Well, the way you're going to do it is as follows. And this, we're going to build this thing, and we're going to walk through lots of times and lots of examples. So I don't expect it to be necessarily instant, but we'll get there. So if you were to draw a link of 128.64.32.8.4.2.1, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's basically what's going on when you look at your subnet bits. For example, this is a /32. This is a /31, which isn't usable. This is a /30. This is a /29. This is a /28. This is a /27. I might be doing some wrong funny math here. This is a /32. This is a /31. This is a /30, /29, 28, 27, 26, and 25. So understand we're going to be playing with subnetting by literally speaking, playing or manipulating with the actual subnet bits. So for example, this is over here, realistically speaking, with a /24, the last octet of host bits, this is what we've got. So you know what we're going to do? I think it's going to come to a better fruition when we work through some examples together. So I'm going to keep moving on and not stop here. But remember, Class A, 8 network bits. Class B, 16 network bits. And Class C, 24 network bits. Okay, so now we're going to do some subnetting, which is just borrowing bits. Okay, everybody tell me right now, 2 to the 16 minus 2, how many IP addresses did that have? Our room was darn close. 2 exponent 16 minus 2. Chetan, sure, let's do this. So, if we're dealing with a subnet, and in this subnet, what we're dealing with is currently this is a /8. So this current subnet right now, for example, 65534 is correct. So right now, here is the Class A. This is what a Class A subnet mask looks like. And that's what it's going to be for the Class A address. So what would a Class A address look like? It would look like as follows. It would look like 1.1.1.1. That would be a Class A address. Now that address itself, being unsubnetted, can go from 1.0, I'm just showing you the range, could go from 1.0.0.0 all the way to 1.255.255.255 for a subnet directed broadcast. This 8.16.24 is 24 host bits. So 2 to the 24th minus 2 is a couple million IP addresses. So there's actually 16 million IP addresses that are in this subnet. But you can't put 16 million IP addresses in a subnet. Or, in fact, you can't even put 500 in a subnet before you run out of broadcasts. So this would be silly. So let's then say, let's further reduce the load here on the subnet. So instead of having 8 bits of subnet mask, let's pick, for example, a subnet mask that we need. Okay, let me ask all you guys an example and chime it into the window. If I need a router which has one link, only one link, and there's one person on one side and there's one person on the other side, how many IP addresses do I need for a connection that can only have 2 people? Okay, so my COO Chris is on this call. If I want to create a connection to Chris, how many IP addresses do I need from my house? How many IP? Anil Kumar, exactly 2. I need 2 IP addresses. Exactly 2 IP addresses. So how many should I use on a subnet to connect me to one person if I only need 2? If I want to be efficient, I'd want to use 2. The reality, it's going to be 4, and we'll talk about why it's going to be 4. But I want to use the least number of addresses possible. So if I've got a point-to-point link between point A and point B, we're not going to use a /8. We're not going to use a /10. And guess what? We're not going to use a /24. We're only going to need 4 addresses. We only need technically 2, but we have to use 4. So what's going on here? Instead of using this, what we would do is we'd further break it down. We'd say, let's take some extra subnet bits, because we don't need the host bits. So by creating more subnet bits, we can create more networks. Now, what I might do is say, wow, we need a 1.1, let's say, we might have a 1.0.0, let me make sure I can type, .0.0.0 /30, this could be an IP address that we'd use, for example, /30. Why would we do this? What does /30 give us? What is a /30? Going back to our binary bits so let's see, of the last octet, so 1, 2, 3, 4, 5, 6, 7, 8. That's our last octet. /30 gets rid of a few of these bits. This is a /32, this is a /31, this is a /30. So a /30 would do the following. It would turn these subnet bits to a 0. And we'll walk through the calculations. So it turns it to a 0. And by turning it to a 0, a room we study networking. This is not AWS, this is not GCP. Regardless of either one of these things, when you're doing a direct connection to room, you're using /30s. It's different between what you do in a VPC and how you connect to a VPC. That's why we have to focus on the network, not what a cloud provider does, because we're designing networking things here. Love the motivation. I love that you love GCP, but we're taking a step back. On AWS and GCP, you still do this kind of stuff on a direct connection. It's the /30. So let's get there. And I also saw Aruni ask the question, what happened to 127? Okay, what happened to 127? Go to a command prompt on your computer and ping 127.0.0.1. Do it on any system in the entire world. Ping 127.0.0.1. What is the 127 dedicated for? It is dedicated towards the internal loopback address of all systems. So that's why 127 doesn't get used. That whole subnet is designed for you to basically test your own system and see if it exists. That is a fantastic question there, Arun. But going back to the actual networking, once we get out of the cloud providers, because you got to deal with real networking, not cloud networking when you're connecting to the cloud, you've got to get these subnets correct. So those subnets are as follows. So this is what a class A that's been subnetted down to a class C is going to look like. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is the binary subnet mask. 1, 2, 3, 4, 5, 6, 7, 8. Now, when you see this, can anybody do the math and tell me what this looks like? I'm going to show you how to do the math, but realize this is 255 in binary, this is 255 in binary, this is 255 in binary, and this is 252. So this, by the way, is going to be your subnet. So when we deal with a subnet like this is the beginning of the subnet, or the network address. We're going to always have a network. Then we're going to have host address, 1.0.0.1, which is going to be a host address. Then we got to get rid of that. 2 to the third is 8 exactly. But it's 2 to the second you're going to do, Arun. You're not going to use a 2 to the third or a slash 28 for a WAN link. You're going to for a WAN link you're going to always use, or 29 you're always going to use a slash 30. And Naga, the reality is IPv6 is not used by much at all right now. It's only used on mobile phones. Maybe 10 years from now we'll be switching over to IPv6. I remember when I first trained on IPv6 15 years ago, and it was all going to happen tomorrow. It's not here. It's very far away. And yes, we're starting to do things, but IPv6 is predominantly just for mobile phones. It may take us another decade to get to IPv6, Naga. That's how far away all the network providers, all the host providers are on the entire networking industry. So yes, that matters, but we're doing IPv4 because 99% of the world's networking outside of mobile phones is all on IPv4. And I know tremendous numbers of CCIEs that have never even worked with IPv6. That's how infrequent it actually is. So I'm familiar with it. I've used it, but most have not. That's how little it actually is. And so it's not going to be replacing anything anytime soon, except for IP mobile phones. But it will be getting there at some point in the future. But 5 years from now, 10 years from now, when that becomes more prevalent, we'll be teaching that as a current skill. But right now, it's a future skill, a skill that's predominantly reserved for the CCIEs like me that are working on mobile phone networks, like 5G networks, because each one of those things has a mobile phone, but not for normal people, and definitely not for most cloud architects under normal circumstances, unless they're cloud networking people like me that are also CCIEs. So that's why we're really focusing on the things that most people need to know. So we're going to have to build these subnets together so you all get it. But really, simply what's happening is we're taking this and we're breaking it down. We're just chopping it up. So that's, realistically speaking, all that's going there. So now how do you plan your network? And we're going to go through hundreds and hundreds of examples today, because you guys are going to know. There's not going to be anybody that doesn't know, but let's just walk through a little bit more first. So what are your constraints? What are you thinking about here as a cloud architect? I can tell you what you're thinking about right now. You're thinking about, how many subnets do I need? How many hosts do I need? If I need 250 hosts, I need a subnet that can support 250 hosts. If I need 4, meaning 2 real, like on a WAN connection, I'm going to use a /30. What if I need 500 in a subnet, which is the maximum pragmatic limit? I can't use a /24 because that only gives me 255 addresses. But poof, I can go to the /23, which will give us 512. So I'll get to that, and it looks like Aaron had a question. Okay, Arun, your IP subnet for the example you gave me is 1.0.0.0. The address used for the gateway in your data center is 1.0.0.1. The address used for the gateway in the cloud would be 1.0.0.2. And .3 is a broadcast which would not be used. So whether that's a router at the cloud on the end, whether that's the router at a branch office outside of networking, it's always going to be a /30. Whether it's GCP, whether it's Azure, whether it's Mike's home network, it's always going to be that way. Doesn't matter. That's the way you create a WAN-to-WAN link. It's a point-to-point /30. Now, in these cloud providers, they have their own ridiculous reasons, like AWS inside of their organization reserves the first 4 and the last 1, so you got to do this. Google does something goofy too that breaks normal networking world, so does Microsoft. But in networking, we use /32s, and for WAN links, we use /32s. For loopback addresses, we use /30 for WAN links, and that's what we're teaching you today. So when you're planning this out, what you're really doing, just literally speaking, is planning your subnets based upon the addresses that you actually need. So let's look a little more about some of these things, and we're soon going to start getting into the fun. When you're looking at masks, remember I told you the 2 to the x minus 2? That's the formula, because you're dealing with host bits. 2 to /30, because you borrowed 2 host bits, gives you 4 total hosts. Subtract 2, because now you're down to 2. Why am I subtracting 2? Because you've got the subnet and you've got the broadcast. We're going to walk through lots of examples. You borrow 8 host bits, which is a 255.255.255.0, basically a class C. If you do 2 to the 8th, guess what? You get 256, but you got to subtract 2 for the network and the broadcast, so that's where you go. You want to use a /23 instead of a /24, you've got 512 addresses. You want to use a /22 instead of a /23, it goes up 2048. You want to use a /12, it goes to 496. a /20. You want to use a /19 instead of a /20, it's going to go to 8192, and so on and so forth, because it's really going to just be based upon these bits and bytes. So let's break it down into more graphics. This class B address, we've got 16 bits of subnet mask, or 16 bits of subnet mask. Now, over here, we could do some additional subnetting if we chose to break it. So normally it would be a /16, so 16 bits of subnet mask. Can anybody tell me what is 2 to the 16th? I think Arun did it pretty quickly before. FAOQ did something info. 2 to the 16th minus 2. How many IP addresses are in this class B network? Two to the 16th minus 2. Okay, if you guys are getting sleepy with the math, I'll pull out a scientific calculator. 65536 sounds about right. So, perfect. That's the /16. So, Arun, since you did the math, let's say we wanted to borrow an additional host bit. And William Wallace is technically right, 65534. Arun forgot to subtract the 2, but perfect. So let's say instead of a /16, let's say we want to do a /17. We're going to lose 1 subnet bit, and we're going to give an extra 1 to the hosts. So what would that look like? If we go from 2 to the 16th minus 2 to a /17, which is going to be a 2 to the 15th minus 2, how many IP addresses are we going to have then? 2 to the 15th minus 2. I know there's this hard delay. So if we go from a /16, which you guys have all astutely done, 65534, and then we go to a /17, meaning we borrow one extra bit here. So here's what a /17 is going to look like. No, /17 versus /16. So if a /16 is 2 to the 16th minus 2, William Wallace, excellent. Minus, I think you may have to subtract 2. So it's going to be 2 to the 15th minus 2. That's how many addresses you're going to get for a /17. How about a /18? 2 to the 14th minus 2. They do a great job. So let's really now let's do this. Let's show you what these subnet masks actually look like in binary and decimal. 255.255. So this is what we're getting out of the class B. Arun, I'm not sure which one you're doing. So we had done the /17, which gets you to the 32766. And then we're going to do the /18, which William Wallace did a great job, 16380. Now let's say we're going to do a /19 instead. Instead of a /18. We're moving over. We're going to basically have more networks and less hosts per network. So so what does this look? Here's what a /16. So we had a /16. So what we had over here. So first we had a 16, then we had a /17, which looked like this. Then we had a /18, which looked like this. Then we had a /19, which looked like this. Now let's have a /20, which looks like this. How many hosts are we going to have available with the /20, which looks like this? 255, 255, 240.0. Arun, great job. It's somewhere around 88190. That's exactly right, Arun. Good job, Arun. Good job, Adele. Now, instead of the /20, let's make it a /21. What's the /21 going to look like? 1.1. Well, so obviously the first two octets are all ones because that's what we 255, and I'll show you how to do the math. Yeah, that's a good typo there, William. You're usually doing a great job, but I've made much worse typos, so I'm with you. So now we have a /21. Great job. 2 to the 13th minus 2. Good job, you guys have figured it out. It's 4094. Okay, great. Now, let's add another one. Let's take ourselves to 252. How many do we have with 252? 2 to the 10th minus 2. Good job there, GZ. So, now let's do this. Let's go make it a /23. 2 to the 9th minus 2. How many do we have? And actually, some people have made some math numbers that are a little goofy over there. Because actually, the /22 should give you basically 1,028 addresses. So somewhere on there, GZ, I'm not sure where or maybe with the delay going back and forth because there's like a 1 minute delay. So anyway, 510 for 2 to the 23rd. Brandon Bowman, exactly. 2 to the 22nd gave you 1,022. Excellent, guys. You guys get it. You guys are getting the knowledge. So /23 is basically 510. /22 is basically 1,022. You guys are getting it. You guys are doing a great job. Let me go reset this to what it is for the next time somebody asks me to do this. And you guys are getting it. We're going to be doing a lot more problems. And then we're going to subnet up. We're going to subnet down. We're going to design IP addressing schemes. It's going to be fun for network. So if you guys are enjoying the network training, type Cloud Architect so I know you guys are here. So now let's walk through some of these subnet masks. And Amrath, I'm not really sure what you have with the number 2 there. But that's okay. We'll have lots of chances to get through a lot more. Thank you guys for letting me know if you're paying attention with Cloud Architect. If you can leave a like, it helps us with the YouTube algorithm, and we really appreciate it. If you can tell others about the free training we do to help the Cloud Architect community, again, that's something we truly appreciate. So 2 to the 8th for a /24, exactly a rune is 254 addresses. There's also another cheat way we could show you, but we want to show you the correct way first. So you guys are doing great here. Now you guys are picking it up. So you guys are letting me know you're here by using the word Cloud Architect, which makes me thrilled. I'm going to go to the next content, which you guys will hear in about 30 seconds from now. Note what we've done here. What I've done in this example is I've taken networking subnets that are and converted them into binary. Because typically speaking, you hear CIDR notation /30, then you see traditional notation, which is 255.255.255.252, and then you see binary rotation, which is a bunch of ones and zeros. So when I see all this stuff, I want to make it clear. Let's go to the top of this over here, right in this section over here. This is what a /32 really means. That's actually not the cheat way I wrote. I'll show you the cheat way. It's very, very cheat way. Well, I'm actually one that'll work almost every time for a /24 and less. So in this example, we have CIDR notation. What is CIDR? Classless interdomain routing. We're going to cover that plenty, don't worry. What is classless interdomain routing? Quite frankly, it's just this. Remember I told you about these ridiculous Class A, Class B, and Class C addresses, where Class A's would basically give you 16 million addresses, and Class B's would give you basically 65,000 addresses, and Class C's would give you basically 254. Well, a /24 is a 255.255.2550, basically a Class C. Binary terms, it's all ones in the first octet, all ones in the second octet, all ones in the third octet, and all zeros in the fourth. Now, this is follows. A /24. So basically, look at it. You've got a 128, a 64, a 32, a 16, an 8, a 4, a 2, and a 1. And when we start counting subnet bits, we count from left to right. So we start moving in this direction. So what does that equate to? If we steal 1 bit of subnet mask, we add a 1 here. So while a /24 is all ones, all ones, all ones, and then zeros, a /25 is a subnetted Class C. We took a bit of host bits and we squished them and stole them and gave it to the network instead, so we have more networks. So what does 128 look? We've got 1 bit here, and then the rest is going to be zeros. So add 1 bit to the 128, and when I ask you guys to calculate the subnet soon, you're going to see why this is important. We've got a 128. So that's a /25. Now, what does a /26 look like? /26, all ones in the first octet, all ones in the second octet, all ones in the third octet. But now we've got a 128-bit and a 64-bit. Can anybody tell me what 64 plus 128? Do the math real quick and pop it in the chat box. Somebody help me with math. I'm not good at math. I practice medicine. I'm a verbal guy. I don't like math. How many tell me I can do math? 64 plus 128. What does that equal? Sim, you got it. 192. Balwinder, 192. Adele, 192. You guys are making me so proud. I am so happy I could cry here. When I see the Cloud Architect community getting good at networking, I am thrilled. You guys are doing fantastic. Keep up the great work. Really, really thrilled to have you. So, you guys got it. So, what does this thing look like? Now you've seen it in binary notation. 255. So in binary, it's all ones, and then we stole 2 bits. In what do you call it? We've got in standard notation, we've got 255, 255, 2592. Does everybody see where we've got the /26 and why? We've got 8 bits over here, 8 bits over here, and 8 bits over here. But we also stole these 2 bits, so 8 16, 24 plus 2. That's how we get to 26. Now, everybody, we're going to have more fun. We're going to work our way. Talani, I am so happy you got this. Awesome, Talani. So, and Ned, great. Just like a Class C, exactly. So classless inter-domain routing, GZ, basically said we don't believe in classes anymore. They're ridiculous. So they're all gone. All gone. That's what classless inter-domain routing is. So now, let's do this. Let's now take 3 host bits and turn them over to the network. So instead of having, 255.255.255.192, we're going to have 3 subnet bits. So we're going to have a 128, a 64, and a 32. Somebody tell me what that adds up to mathematically speaking. I'm not Mr. Math. My wife is. She can do calculus in her head. I'm not Mr. Math. That's why I have super smart quantitative data scientists on my team, because they're great at it. So, somebody tell me what is 128 plus 64 plus 32, and you've now figured out the /27 subnet mask. Add them all up. Balwinder, excellent. Arun, excellent. 224. So what do we have here? We have 255.255.224 or /27. How did we get to 27? 8 plus 8 plus 8 plus 3. Makes sense. So, now here's the cheat way to figure out how many hosts we're going to have in the subnet. How many hosts? We take 226 minus the subnet mask minus 2. So if we took 256 minus 224, that'll tell you the maximum number of hosts. And then you subtract 2, the 0 and the broadcast, and now you get it. So now you guys, we're backing in, we're backing out. We're going to summarize and go up. We're going to go down. We're going to go all up and down on this chart. So now let's do a /28, which, oh, by the way, is the smallest subnet you could potentially use in the AWS cloud. Would I use a /28? No, I wouldn't. Because it's ridiculous. Especially in AWS. I'm going to use, and as a rule, here's the recommendations I have for you. WAN links, /30. There's only 2 addresses. LAN links where your servers are going to be, /24. Why? You're always going to need 10 times more servers than you think you need. It's just a matter of time. And on the cloud, you're going to be auto-scaling. Your load balancers are going to be scaling. Your servers are going to be scaling. You got to scale this stuff out. If it doesn't scale out and grow, your systems don't grow. So for the cloud, the smallest one that I recommend is a /24. And I recommend a /24 being, generally speaking, the smallest address space you ever use in a LAN interface. /30 is typically used on a WAN interface. /32 is typically used for a loopback. Every network architect in the entire world does this. Okay, so GZ, let's you've asked a valid question. So what's going on? Where do these things come from? So GZ, what is 2 to the 8th? 256, right? So 256. So the way this would work exponentially is you would have a 1, a 2, a 4, an 8, a 16, a 32, a 64, and a 128. So because that's the way it exponentially would work, and we subnet from left to right, meaning we're borrowing bits from the hosts. So how do we get to 256? Let's take 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 and plus 1. Somebody add that together. I'll add it too. We'll take 224. Oops. Plus 4 plus 2 plus 1. That's the 255. So for example, oh, you can't see my phone. So if we do 2 to the 8th, that gets us to 255. So we're just adding them all together. Exactly, Greg, you got it. Perfect. But we are starting from the left and we are going to the right. And why are we going from the left to the right? Because that's the way subnetting's done. You guys are doing fantastic. I'm super proud. So, perfect. So now let's walk through this just a little bit more. Let's go to the /29. It's going to be all ones for the first octet, all ones for the second octet, all ones for the third octet, and then it's going to be 1, 1, 1, 1, and 1. So we've borrowed 5 of the 8 bits. So we're going to be using a 128 plus a 64 plus a 32 plus a 16 and an 8. So somebody add them up for me. They can tell me what the subnet mask is going to be. Come on, you guys are doing great. 128 plus 64 plus 32. Nice. Good jobs. Excellent. So, 256 minus 248 divided by 2. How many host addresses? That's the cheat way. Or you can do 2 to the third minus 2. You have to actually start with 256 to get to the 248. To calculate the number of hosts, you're going to start with a 256. Why do we start with 256? Because in the US, we start counting at 1. And the remainder of the world, we start counting at 0. So when we're dealing with these numbers, we start counting at 0 on the way to 255, and that's how we get to 256. So we can do 256 minus the subnet mask, which is 248, which will give us 8 minus 2, which is 6. Or we can do 2 to the third minus 2. Arun, you got a cigar, you figured it out. Great job. Totally pleased, totally happy. So hope you guys got that. Now, let's go from the /29 to the /30. Most common WAN link in existence, /30. What's that going to be? Oh, it's going to be a 128 plus a 64 plus a 32 plus a 16 plus an 8 plus a 4. What's that going to look like, everybody? Okay, sure, Balwinder, I'll repeat my cheat way. Now, Balwinder, for someone like you that's got good math skills, I don't recommend using the cheat way. But for someone like me, and good job, Arun, that doesn't love math, is each one of these octets at full capacity, note it says 255, right? So let's look at this. What's 0, 1, 2, 3, 4, 5, 6, 7, all the way to 256. All the way to 255, it's actually 256. So what we're doing, Balwinder, on the cheat way, if we want to figure out how many hosts per subnet, is we're taking 256, which is the total maximum number per subnet, because we're starting at 0. We subtract the subnet mask, and then we minus 2, and that will always give us. So if we had a /30, for example, which is a 252, we could do 256 minus 252, which gives you 4. Subtract out the 2, and we've got 2 usable addresses. Or we could do 2 to the third, or 2 to the second, which gives you 4. Yeah, wait, I'm doing something funny with math. Let's just go there. But that's the way, realistically speaking, it works. So now let's do a /31. The /31 is a subnet you will never, ever, ever use in life because you can't use it. Because when you're dealing with the subnet, the first subnet is a 0 and the last one is a broadcast. So in a /31, you've got a total of 2 addresses, meaning this is the broadcast and the subnet. So you can't use that, but you can use a /32. What is a /32? A /32 is a host address. And you might see a host address on a router as a loopback address, and it might look like this. And it's just an address that you push there. It's a host address. And so I can put this on one router, and the next router I can put this /32. And basically it's a way to truly maximize address space. But this is only used as for loopback addresses on routers. So I would say, unless you're a routing and switching person, you're never going to use anything smaller than a /30. /30 is used on a wide area network, point-to-point link. Trying to mute all of my notifications. Bear with me. busy executive, I typically get about 100 Slack messages, 100 emails, and about 100 text messages per hour, plus, at least a dozen phone calls. I have them on mute, but that's typically just the story of my life, so bear with me. So, let's play with this now. So, I want you guys getting it. I don't want anybody leaving any of my training without really knowing what they're doing. So feel free to ask questions when you got them. For the next thing, to let me know if you're having fun, let me know by typing Cloud Architect. That's how we know that people are there. We love the Cloud Architect community. And let me know if you're seeing it, watching it, and having fun with Cloud Architect, and then we're going to enjoy more fun. And while I'm waiting for some people to let me know that, we're going to go on the subject project. You just want to know that you're there. Although you guys seem to be doing a pretty good job. Arun, you're one of my students. You don't think in terms of GCP, ever. You think in terms of designing the solution for the customer, because that's the TOGAF way, that's the enterprise architect way, it's the cloud architect way. If I know I need a compute instance, it doesn't matter to me whether I go to Google Compute Engine, AWS EC2, or Azure. It's all the same. That's just the name of a brand. If I go to the store to buy a shirt and I want a cotton t-shirt, it doesn't matter if it's Nike or Ross or Adidas. It's just a shirt. So we got to think in actual terms of what we're designing. Doesn't matter what Google wants. Doesn't matter what AWS wants. Pick the right subnet. What subnet did I tell you guys to use for LAN links? A /24. What did I tell you to use for LAN links? A /30. It works on every cloud, every data center, every network, everywhere, anytime. So I don't ever want someone to focus on a single cloud. You will never in real life be just on working on a single cloud in today's modern world. It's going to be a hybrid cloud. It's going to be a multi-cloud. It could just be all the data center. Or it could temporarily be on a single cloud, exactly, or in /30, migrating to multiple clouds. And if we only know one cloud, it'll be miserable. When I go to Greece, I think in Greek and I speak in Greek. If I tried to think in English and translate it to Greek, it wouldn't work. Focus on the big picture. That's what an architect designs. From there, it's just a matter of picking out the services per cloud. You guys are doing great. So we're going to do some more subnet training, but my team has reminded me that I should post a link to our training, so I'm going to do so. My team has also reminded me that I should post a 20% discount coupon code for anybody that's interested in training. And my team has reminded me that for anybody that's interested in signing up or asking questions about our training, that they can, what's the word I'm looking for? They can call our office. So let's get back into some fun training now. Going back into our super fun training and experience time. Now let's go back to these slides. So I'm going to start with Arun. You've been pretty vocal. Now we're going to pick people out of the group. I want you to tell me what is the actually, you know what? I'll do the first example. And then after that, Arun, you're going to do the second one. So let's take this particular IP address, 192.168.1.132. Now, what does that really look like in terms of, let's look at CIDR notation. And actually, as Chris said, Chris could potentially be asking. The reason I tell my students to use Slack is the corporate phone gets used by multiple people per day. So if you want to reach me, use Slack. Because Chris might answer and my wife might answer. She's also involved in the company. Somebody else might answer if you call her primary number, but that's what she was saying. But we will definitely call you back. And anybody that's got a true question for me about our training, I will get back to. And any of my students can reach me via Slack, or they can reach Chris, who's available to make sure that everybody does well. So let's look at this actual address. If we look at a /25, it's going to look like 255.255.255.128. That's what it's going to look like. In binary, it's going to be this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, 4, 5. I may have actually miscounted, but that's what this is going to look like, architecturally speaking. So I need someone to tell me where the subnet begins and where the subnet ends. For example, where does this subnet begin? /25. This is what it looks like. Does anybody know? So typically speaking, the first address of the subnet is usable. Is restricted for the network. The last IP address of the subnet is restricted for the broadcast. Does anybody know where this 192.168.1.132 subnet begins? If not, I'm going to walk you through it. Okay, well, I see no answers, so I'll walk you through it. If we look at 192.168.1.132, Arun, great job, it's 128. Does anybody else know how Arun got to 128? Where the subnet began? Subnet begins, Abby, at 128. Okay, so when we're dealing with calculating the subnet and calculating the broadcast, the subnet is all zeros. So what is this? What is this plus all zeros? It's 128. But if people didn't get this, and I think a lot of people probably didn't, let's be real answers. 132 is the address that you guys were given, right? Is 122, what's it divisible by? Is it divisible by 128? Yes, with change, right? Is it divisible by 128 plus 64? No. So the subnet's going to begin by what it's divisible by. 132 is divisible by 128, and it gives you like 1 point whatever and change. So that's your answer. But it's not divisible by 192. It's not divisible by 120. I'm sorry. What's the word I'm looking for? It's not divisible by 192 with a whole number. So you need the largest whole number. What is there by the largest whole number? What do I mean by that? 128. So it must be there. It must be there. 1 second. And Kisha, we're actually going to get to your questions. One of the MBAs on my team is going to answer that. We want to teach you to think like an architect because, it's pretty important. I want you to really, really understand how to do architecture, and whether it's planning your career or planning dealing with your customer, it's the same process. So for example, let's just take a break into architecture. Kisha said the course was too costly. If the average architect learns $600 a day and somebody gets you a job 3 days sooner than you would have on your own, that's an $1,800 value to you. Even if the course was $1,500, you made money by taking the course. So if a course, for example, cost you $10,000, but it raises your salary $100,000 a year, it's the cheapest $10,000 in the world. So as businesses and technology folks, we're going to get back to this, when you're designing a solution for a customer that's going to cost $200 million, and a $200 million architecture is nothing. I've sold multiple billion-dollar architectures before. And peace be with you as well, hand of God. If the $100 architecture doesn't save your customer any money, a $100 million architecture is expensive. If you sold the customer a $300 million architecture and they saved $1 billion a year, it's the best investment they've ever placed. So I spent $250,000 in education, but retired at 34. That $250,000 was awfully cheap. So it's a matter of, doing ROI modeling on everything that you do. Is education expensive? Yes. Good education is expensive. Is the education going to be more than paid for by building your career? Then it's worth it. If the education does not create a greater value for you, then it's not worth it. A $50 Udemy course that doesn't get you hired is a $50 expense. A $5,000 course that raises your salary $100,000 a year is awfully cheap. So look at it that way. Best way I can describe it. I'm saying this because whether it's training or architecture, you still have to do that same ROI modeling. You must do that for your customer. So if you're not learning it from me because it's expensive, that's fine. Get an MBA. Go take ROI modeling training. You've got to do it. You have to know how to do this as an architect. So I want you to be successful. Train with us, great. Train with somebody else, great. But you need these jobs. And you don't suck. Nobody sucks. We'll get you there, Carrie. If you're struggling, we'll keep going. We've got hours and hours and hours more to go, and nobody's going to be left behind. No one. So we'll make sure you all get it. You'll definitely get into this. You'll get any job you want. Let's just eat right, think right, train right, and we can accomplish anything. So, Arun, you did a good job. The 192 is divisible here. So, Arun, you told me where the subnet began. 192, 168, or I'm sorry, .1.128. Now, Arun, where does the, Carrie, if you've got an issue, call our office and we might be able to work with you. Arif, so happy to have you. So, now, Arun, where does that subnet end, since you know where the subnet begin? What is all ones? Meaning, if you added a 1, a 1, a 1, a 1, a 1, a 1, and a 1, what does that look like? Arun, you still there? So if 128 begins the subnet, where does that subnet end? What's left? Let's add the 64 plus the 32 plus the 16 plus the 8 and the 4 and the 2. What's that going to give you? $126. So happy you're here. So the last usable address, Nick Love, is 254. Great job. Theo Q, the broadcast is 255. The last usable address is 24. Ran, I'm sure you meant to say 255. Derek, 255. You guys have got it. The broadcast is 255. Then the subnet is 128. The broadcast is 255. The usable addresses are 129 all the way through 2024. Don't worry if you guys missed this. We're going to do a lot more examples. Okay, next one. We're going to go left to right. So, somebody over here that wants to take this challenge. Arif, you like networking? You're first. Okay, 172 Arif, 16.1.27/27. What does the /27 subnet mask look like, Arif? 255 plus 128 plus 64 plus 32. That magic number is 224. What does it look like in decimal and binary places? It's going to look like this. Okay, calculating from right to left. There, which is one of my favorite things to do. Calculating, I read in multiple directions depending upon where I'm at. Some places read in one direction, some places read in another direction. It's all good. But in subnetting, we read left to right. Just like most American movies, left to right, and American books. So, left to right. So, when we start talking about these things, or Arif, since you like networking, which I'm thrilled, where is the beginning of this subnet? Let's take 27 and divide it by 224. And let's come up with a, well, actually, before we do that, is 27 divisible by 128? No. Is it divisible by 64? No. Is it divisible by 32? No. Is it divisible by 16? The answer is yes. So that should help guide you, Arif. So Arif, where is the beginning of this subnet? Where is the end of the subnet? And if I put you in the spot and you just popped in, you can just say, Mike, I'll do the next one, and I'm totally respect that. Or the one after that, it doesn't matter. But where do we begin this subnet? It's divisible by 16. So what would a subnet look like? 0 to 15 would be the first subnet. What would the next subnet be? 16 to 32, or 16 to 31. So, somebody tell me where this subnet begins. The 172.16.1.127, realizing subnet 0 goes from 0 to 15, subnet 2 goes from 16 to 31, subnet 3 goes from 32 to 47. Balwinder, you got it, 16 to 31. Reef, you do great. I've seen you in class. You're super smart, super capable, and the things you accomplish are awesome. So, If I threw you on the spot within 3 seconds of you saying, hi, Mike, I'm here, don't worry about it. Arif, you are doing fantastic, literally fantastic. So, all good. So, Balwinder got it. Perfect. Somebody else. This is going to be a Christian, this is not going to be a /224, it's a /27. Oh wait, a /27 is a /24. Apologies for that. So 128. So we have ones for the first 8, ones for the second 8, ones for the third 8, and then we have a 1, a 1, a 1. So Christian, 128 plus 64 plus 32 equals 224. Or Chintan, I hope I answered your question there, Chintan. If I have not, let me know and we'll go back to you. I want you to make sure you got it. So in Chintan, because we were dealing with a /27, and a /27, basically the host per subnet is 256 minus 254, 224 minus 2. What does that realistically mean in terms of hosts? 2 to the 5 minus 2. 2 to the 4th is 16. 2 to the 5th is 32. So, yeah. 2 to the 5th is 16 minus 2, which gives you 14 addresses. So the way this is going to look for a /27 is as follows. You are going to have a 172.16.1.0 all the way to 115. Then you're going to have a 172.16.1.16 all the way to 31, the next subnet. Then the next one is going to be 172.16.32 all the way to .47. Then the one after that will be 48 all the way to 63. And the one after that will be 64 plus 16, which I think is 78. And it goes on and it goes on and it goes on. When you're teaching a course and responding to 4 different messages all at the same time, sometimes your arithmetic in your head gets a little goofy. So apologies for that, but I want to make sure you're there. And okay, now here's a special use case, a /32. This is called a host address. This is what this looks like in binary terms. 1, 1, 2, 3, 4. This is what it looks like over here. Now this is only used for what's called a host address or a loopback address. Only. But let's talk about what that really means. Where does this subnet begin and end? It's going to end and begin on a single address. Why? This is a /32. /32. So, how many addresses are available on this subnet? How many? We don't have 128, we don't have 64, we don't have 32, we don't have 16. We have 1. So we've got 1 available use for this subnet. So for this 172.16.1.127, that's the whole network. The whole thing. So the only time you will ever use a /32 in your life is if you put a logical address to identify a host. Only 1 host on that subnet. So you guys get it. Now, let's now deal with this one, this 192.168.1.17. Let's take this. Let's look at it. So first, it's a /28. So what does that really mean? 128 plus 64 plus 32 plus 16. Somebody do that math for me, so I don't have to be Mike the mathematician. Somebody add 128 plus 64 plus 32 plus 16, and that way I know you guys are happy learning cloud architects out there. And great, Indra Kumar, fantastic. Great, Gopal, great, Derek, great, Theo. Nick, perfect, Balwinder, awesome. Del, well, okay, good job. Nice job. You got it. 240. Great, Adele. Great, Balwinder. You guys are making me proud. Gonna make the coach actually so happy he's gonna cry. Okay, really great job. So it's gonna have to be divisible by 16, Anil Kumar. Great job. So where do you think this subnet begins? can you, so the 192.168.1.17, just like on Great Job Around, William Wallace, Jay, Derek, awesome. Thrilled. Arun, you guys got it now. So, /240, what's that look like? Well, let's knock out these 4 last bits. Just swap them over to 0. How many hosts on this /28? Real hosts in IP networking, not AWS or GCP networking. That number is going to be different, and we'll walk through those problems soon. So 2 to the 4th minus 2. I'm sorry, it's 2 to the, 2 to the 4th minus 2. That'll tell you exactly how many addresses. So 16. Great job, Adele. So if we know that it's 16 and this thing's beginning at 17, where does the subnet begin? 16. Val Wonder, you got it right. There are 14 usable addresses. 16 minus 2. Rantal, you got it. Nick Love, you got it. Adele, you had the right number of addresses. You just forgot to subtract the network and the broadcast, but you got it. William Wallace, 256 minus 240 will give you the number of addresses that you actually have. Indra Kumar, you've got 1 too many. 2 to the 4th minus 2. 16 minus 2. Why? Because 192.168.1.16 is the network, which is not usable, and 192.168.1.31 is the broadcast, which is again not usable. So every address from 17 all the way to 30 are going to be usable addresses. Now, if you're on AWS, they do something ridiculous. They reserve the first 4 and the last IP address, which basically means you'll have 11 addresses. Why is this so bad? If you're planning on having 14 addresses and you only have 11 and autoscaling runs out of autoscaling addresses, then poof, your systems don't scale. So the /28 is 14 available hosts. Good job, everybody. You guys got it. So let's do another /28. Let's do a 172.17.1.19. Does this look that much different than the last one? I mean, we're dealing with a 172/28 versus a 192. Does it matter? Is the math identical, even though this is a subnetted class B versus a subnetted class C? That's why it's CIDR, classless interdomain routing, because it doesn't matter. So, somebody tell me here, where does the subnet begin? Where does it end? And what are the usable addresses in the subnet? Guess what? It's going to look a lot like this one over here to the left, where we just did. Somebody help me here. Work with me. Somebody help me out here. Okay, Derek, I don't see where you're getting this one. So, 14 are usable, correct? 16 to 31, or 16 to 30 are the usable addresses, Kumar. 31 is the broadcast. So the subnet begins at 16, Arun, and it ends in 31. The subnet, the address you see isn't where it begins. Where it begins is in these multiples where it's divisible by, as whole numbers. So 19, if we were to take it into 16, it's 1 plus change. We don't do change when we're dealing with subnet math, so it would be 16. So it'll be 172.117.1.16, and then 30, it'll be 16.30 that are usable. 31 is going to be all ones broadcast, so you're there. Okay, Balwinder, great job. And let's do one more. Well, let's do 4 more, because then we're going to do some other fun stuff as a group. I think you got it now too, Arun, but I want to be certain. This stuff is just super critical, so we want to know you got it. So working through some of these things, let's, it begins at 16, which is the network address which the router uses, not a host, and it ends in 31, which is if you wanted to send a broadcast. Exactly. So now let's do this. 172.17.3.19/29. What does 29 look like, everybody? Okay. .248 or 11110. So what is 1110? Add this, add this, add this, add this, add this. And now you're good. So how many times is 19 divisible by 8? Nine times 3 is 27, right? Or 8 times 2 is 16, and 8 times 3 is 24. So I ask you, how many times is the .19 divisible by 8? Twice, right? So, Balwinder, Arun, if this thing begins because it's divisible by 8, which is 16, where does that subnet begin? Femi, good job. Derek, good job. Alonzo, fantastic. So you guys get it. It's all divisible by 2. Fantastic, you guys get it. So now, wow, let's look at this. 8 times 2 equals what number, everybody? Nice job, Galani. Nice job, Suba. Well, actually, Suba, you were almost there. Gary, don't worry. You can learn this. You don't need to stay in retail. You can do so many things. Don't be sad. Put the effort in. Nothing good comes easy. I will tell you this. If it was easy, everybody would be there. Because it's not easy. That's why you have the opportunity to put your time, your effort, your heart, and really focus your mind on something for 6 months to really master it. And when you master it, watch your life get into incredible things. So I expect good things to be hard. Nothing good is ever easy. If it was, it wouldn't be good. It would just be average. So exactly, William Wallace got it, Derek got it, Nick Love got it. It's going to start at 16. That's where the subnet begins because it's divisible by 8. So it begins to 16 and it goes up to a total of 8. But we start counting at 16. So we've got 16, 17, 18, 19, 20, 21, 22, and 23. Like Derek from my team says there, Carrie, you just put in the time, you put in the effort, we can all achieve anything we want. Anything. It's just don't quit. Why do they put Navy SEALs through the most miserable training in the world? And why do they put SAS commandos in the most miserable training in the world? Because they want to push them to see who quits. And those who quit don't achieve it. Do you know who stick around in the end? The winners. So when it's hard, you got it. I read 75,000 pages of reading just to become a CCIE in 6 months. I felt sick every day. I threw up 3 times right the day before the exam out of anxiety, but I did it. So don't worry about it. You've got it. Take a couple deep breaths. Believe in yourself. You can do it. I promise you, you can. Stay strong. That's how people get to good goals. One of the Navy SEALs that I know very well said to me, he said, I would never do this because I love elephants. He said, if you have a monstrous task like an elephant, eat it one bite at a time. Little by little by little. You take one thing, you win. You do the next thing, you win. You do the next thing, you win. And you know what? Some days subnetting's easy. Some days subnetting's not right. Watch this another day. And today, if subnetting's hard, go learn about virtualization. You'll get there. Fight hard, fight to win, and achieve everything you've ever dreamed. And then write me an email about how great your career is, because I know you can do it, and I want you to get there, Carrie. Never quit until you get your goals. So that's the way I live my life. So now we're here. So you guys figured this one out. Now let's do the next one. 10.0.0.2/30. So what's that subnet mask look like? Looks like this. What does it look like in binary terms? It looks like this. So if William, great. If the division is even, we're going to start at that number. If it is not even, we're going to start where it would be even. So in this particular case, I'm not really sure where you're at there, Philip Houston. So what's going on here for this 10.0.0.2/30? Let's talk exactly about what that is. It is a /252, exactly, Arun. So now I updated the bottom, but not the top. Yeah, I did the bottom one and not the top. So exactly, /30, 252. Here you've got your one. So 2 usable addresses. Great job, freak mode. Where is the beginning of this subnet? We're actually on the 0 subnet here. So if there's 4 total addresses, minus 2 which are not usable, where does the 10.0.0.2 subnet begin? Where does it end, and what are the usable addresses? Okay, Adele, you're almost there. 0 is the network, .1 and .2 are usable, and .3 is the broadcast. So, Rand, good question. We can have a network that have 20 different kinds of subnets on the network, and we always will. Always will. William Wallace, you got it perfect. Now, if 2 hosts want to talk to each other, they have to be on the same subnet. If they're not on the same subnet, they actually can't communicate to each other without going through a router. So if you've got a 192.168.1.0/24 and a 192.168.1.2/29 on the same subnet, they can't talk to each other because they're on different subnets. But okay, Nigel, you got it. Adele, you got it. Jay, you've got it. Talani, okay, I want you to watch this again, and I think you're going to get it. I've watched you learn so much so fast, so either you're going to get that, or we're going to keep doing examples. I know it's going to click for you, Talani. Now let's go over here to the /24. Next. This is what this subnet mask looks like. Now this one's going to be pretty easy to calculate in your head. You should know where the subnet begins, where the subnet ends. 2 to the 8th minus 2 gives you the number of maximum addresses. How did I get 2 to the 8th minus 2? 1 bit, 3, 4, 5, 6, 7, 8. So that's the only way I did it. So what does the subnet mask look like? Add this, plus this, plus this, plus this, plus this, plus this, plus this, and you get 255. So here's the subnet. How many hosts on this subnet? 2 to the 8th minus 2. What's that number? You got the total number of addresses there, Arun, but we can't use the 0 or the broadcast. Okay, this is a /24. 2 to the 8th minus 2. Or 256 minus 0 minus 2. 254 addresses exactly. So somebody tell me where this subnet begins. Where does the 10.0.0.9 begin at /24, and where does it end? Where's the broadcast? Nice job, Adele. 1 to 254. They're the usable addresses. So where does this subnet begin? Meaning the one, which is an address that's not usable, Adele, right beneath the 1. What's that subnet, Adele? 1 minus 1 equals. That's your subnet. And what is broadcast? You got it, Spellwinder. Is 10.0.0.255. So that's the broadcast. So where is, and Adele, 0, you got it, is the subnet. 255 is the broadcast. And the usable addresses are 1 to 254. Fantastic, Adele. Great job, Gopal. Balwinder, fantastic. Freak mode, great. Arun, you got it. Nigel, great job, all you guys. So, super proud. Let's do this last one on here, and then we're going to start doing some more fun stuff. We may be going up and down, and then we're going to start designing systems together. And then we'll be putting some addressing schemes for the system. So now let's talk about what this is going to look like. 10.1.1.0/30. What is /30? It's this. One, two, three, four, five, six. 6 subnetting bits. 1, 2. /30. Want this plus this plus this plus this plus this plus this. /30. 2 to the second minus 2. How many addresses is that? Total usable. 2 to the second minus 2. Total addresses versus usable. 2 to the second minus 2 is how many usable addresses? Adele, great job too. So now let's work through this situation. 10.1.1.1/30. 2 usable addresses. The one beneath the first usable address is the subnet. The one right above the usable address is the broadcast. Somebody tell me what the subnet address is and the broadcast address for this? Zero to 4 total, 2 usable. So now, which one of these are? Where's the subnet? Where does it begin, and where's the broadcast? Okay, 0 to 3 are all addresses, Adele. Perfect. The 0 is the subnet. The 3 is the broadcast. So Adele, which 2 are usable in between them? Arun, you got it. Nick, you were almost there. 0 is the subnet, 3 is the broadcast. William Wallace, 1 and 2 are usable. 0 is the subnet, 3 is the broadcast. Bowender, you got it. You got the broadcast. And Chai Chen, you did a great job. Shapur, you're almost there. 0 is the subnet, 1 and 2 are usable, and 3 is the broadcast. Great job. Alex, you got it. 1 and 2 are usable. Amaranth, good job there. And William, 0 is the subnet, 3 is the broadcast, and 1 and 2 are usable addresses. And Derek, you got it. It's a /30. So, now we just broke subnets down from big networks to little networks. But, what if we wanted to go the other way? Now, why would you want to go the other way? So, let's say you're working on a cloud like AWS. You would do it for lots of reasons other than AWS. But, normally speaking, when I connect to the internet with a big internet router, I'm using BGP. And through BGP, if I connect to 10 different internet service providers, I collect 750,000 routes through one internet service provider, 750,000 routes to the next one, 750,000 routes, 750,000 routes. In the end, I'm taking in about, on a normal internet router, 7 to 10 million routes. Because these routers can handle it. Now, when you're dealing with AWS, they only let you do 100 routes. So think about this. 10 million in an internet router, 100 routes with AWS. So basically, AWS has handicapped you about 1,000,001% over the capabilities you would have Alpha the cloud. So you guys all know that I love the cloud because the cloud enables business agility, the cloud enables auto scaling, the cloud enables speed, and the cloud enables people in the developing world to buy technology they never had before. But don't think the cloud is as good as the network in the data center, because it's not. It's slower. It's a virtualized network in a data center. When you virtualize something, you reduce its performance, and that's okay. Now, there's times where you reduce performance a little bit, and there's times where you basically say, we can only handle 100 routes. Let me tell you, if you deal with any enterprise organization, they're going to have 50,000 internal routes. 100 routes is nothing. It's almost a joke. And it's actually a joke of a joke. It's so silly. So when you're dealing with these environments, and we used to actually have to do this like 10 years ago or 15 years ago, back when routers had a 10 megahertz CPU and a meg of RAM or 2 megs of RAM or even 16 megs of RAM, we had to deal with small routing tables. Now we haven't had to do that in 20 years because we've dealt with better routers. But now with AWS, we have to reduce our networking capabilities basically 20 years worth to go work with them. So, okay. So we've got to summarize routes. What does that mean? It means taking routes and creating new routes that equal the same thing. So now let's look at this particular environment. Let's say we're here. Let's say, for example, we've got this 192.168.0.0 and a 192.168.1.0. Now I could send this route in one subnet as an advertisement, and I could send out this subnet. Okay, actually, before I talk about route advertisements, let me tell you what they are. So let's say I'm here. Derek, you're on this call. Derek, I know you well. So let's say, for example, Derek is at his house, and I'm at my house, and we set up a BGP pairing session between us. BGP is a TCP-based routing protocol that's used to connect to external entities and exchange routing information that's scalable. When I connect to Derek, I could send him, or let's say I have the subnet 192.168.0.0 and 192.168.1.0. I could send him two routes and say, Derek, come to me for 192.168.0.0 and come to me for 192.168.1.0. If I send him two routes, I use up two routes. Now, normally speaking, no big deal. AWS, 100 routes, two routes to connect to two people, you got a problem. So, does anybody think that you could possibly go the opposite direction as supernetting and literally go up one level, for example? And instead of having a /24, create a subnet that would include these two things? Can anybody think about what that would look like? Give you a hint. 192.168.0.0 and the .1 could be summarized as this with a /23. This address will literally provide reachability for both. And what's that subnet mask going to look like? It's going to look like 255.255.255.254. That's what this mask would look like. Now, I still got a bunch of other addresses. What if I wanted to send a single route that included 192.168.1. Oops, didn't mean to do that. How do I get out of this? Because let's say I had all these things and I wanted to send a single route. Can anybody think of a new subnet mask that would? I'm sorry, /20. I'm sorry. This should have been 254 here. This is what happens when you do math in your head while you're teaching, communicating, and responding to messages in a chat window, trying to see things. So this is going to be a /23, which summarizes the 0 and 1. What if I want to go 0 all the way through 3? Oh, Ren, you got it. /23. William, you can always watch the replay. Piano lessons and skills. Anytime we learn, it makes us better in any way, shape, or form. That's great. Thank you for attending and look forward to seeing you on another day. So can somebody tell me what kind of a subnet mask we could use for 192.168.0.0 that would include all four of these subnets? Can anybody tell me? Come on, somebody. Okay, exactly, Arun, /22. So by doing this, by changing this to a /22, exactly everything's going to change. So it'll look like this. And what is a /22? 6 bits. What are those 6 bits? Let's add them up. 128, 64. I don't want to confuse you guys by getting too complicated. But we can summarize the 1 to 3 with a /22. Excellent. Now let's do the same thing for these 10 subnets. Now, these are going to be a little trickier because not all of these things are going to be easily divisible. Actually, I'm going to make them divisible. Now let's do it over here for the 10 subnet. What's the summary address that gets the 0 and the 1 together? Erica was actually a great question. We used the /23 to cover the first 2 because the 23 gives us 2. We used the /22 to cover all 4. So it's just a matter of how many that we actually need. And it's because these are contiguous subnets. Hope you got that, Eric. If not, we'll find a time. So exactly, we're going to use a /23. But what does that /23 look like? Somebody tell me what this /23 subnet actually looks like that encompasses these two. Somebody write it out in CIDR notation for me. CIDR notation, just to let you know, would look like 172.16.0.0/16. I intentionally chose, that's CIDR notation, whereas conventional notation would be this. Well, with the .0.0. And folks, I'm really sorry for sitting behind a slide presentation for this. Sitting behind a presentation without seeing someone is not something I like to do. I like to be out there front and center like a real presentation would be. It's just that I had to use certain slides for some of these numbers. So somebody help me here. Somebody tell me the CIDR notation for this exact block. 10.0.0.1. What's it going to look like? Arun, you got it, but write it out for me. Put it in the chat window. What is this thing going to look like? And if anybody doesn't know, I'll pop it in the chat window for you. Yes, exactly. That's the /23. But I want the whole subnet, Armora. What is 10.0.0.0/24 and 10.0.1.0/24 combined to both the subnet and the mask? So I need something with a 10 dot something and then the subnet mask. And if you guys don't know, I'll do it. So I'll help you folks with it. What does this aggregate summary look like? Because this is basically with the summary route that you're going to see on your router. It's going to look like this as follows. It's going to look for the /23 as a 10.0.0.0/23. So what we were doing before is we were going from big to little. Now we're just going the opposite direction from little to big. So okay, so let's take a step back if you guys are struggling with this. Let's go bring this back. Let's go to 192.168.0.0/24. How many hosts in this subnet? There's a 60-second delay, so by the time I speak and the time I see your messages could be a minute later. I mean, you guys got the subnetting. Now we're trying to do supernetting. Okay, exactly. You've got 256 minus 2. So 254 and a slash 24. What if we needed to subnet the size, double the size? What if we need to double the size of a slash 24? Let's say we need 500 hosts instead of hosts. How do we go the opposite direction? So when we subnet, we're making something big. So if we need 254 usable hosts, we use a slash 24. If we need 126 usable hosts, we use a slash 25. If we need 512 hosts, what do? We can't take the slash 24 because it only gives us enough hosts for 254. We need to go to a slash 23 to get to 512. That's the next available thing. So that's why we go subnet in the opposite direction. Now, what do we need if you can't do it, but because of broadcast, but what would you do if we needed 1,000 hosts? We can't get it in the slash 16, right? I'm sorry, we can't get it. We can't get it in the slash 24. If we needed 1,000 hosts, we would need to do a slash 22 because a slash 24 gives you 256. A slash 23 gives you basically, or 254 gives you basically 254 times 2. What if we need to double the 1024? We'd use a slash 22. So that's all we're doing is we're just going up versus down. Before we were going down. Now we're going up. So if I were to say 192.168.0.0, 253 or 4 hosts, 192.168.1.0, that's the next subnet up, and that's 254 hosts. And we did 192.168.2.0, that's 254 more hosts. And the 192.168.3.0, that's 254. So 254 times 2 equals what? Or times 4. I'll do it. I'll pull out my trusty rusty iPhone with my great Mac skills. 254 times 4. 1,016. So that's where we got to the slash 23. That's how we did it. Now, I'm sorry, not the, yeah, this. So now let's look at this. 192.168.0.0 slash 22. Would help if I could type. So now do we see where it's coming from? I just went in the opposite direction. So slash 24 is going to cover the first subnet. Now the next subnet down is this 192.168.1.0. So we need a bigger thing to hold this root and this root. So we have to go from right to left this time. Before we went from left to right to shrink it, now we need extra host bits. So instead of the subnet mask looking like this for each one, 255.255.255.0, we need one more. We need to steal a bit over here. So we're going to steal a bit over here by making it a 254. So now we have our 8 bits over here plus a single bit here. So realistically what's going on? We've got 9 subnetting bits, or 9 host bits. So what do we have over here? We have 8 plus 8 is 16 plus 7. What's 16 plus 7? It's a slash 23. That's how you got there. No different. Now, does everybody see how this and this now equal 192.168.0.0? Let me know, guys, before we move on to more complicated topics. Rantel, you got it. Good. Nick Love, you said it's starting to make sense. Adele said you got it. Eric, no. Alex, you got it. We're almost there. So, Eric, let's take a look at it another way. Sure. So, Bellwinner, I'll do it one more time, and then we're going to keep building on this. So, 192.168.0.0 plus 192.168.1.0. Now, these are contiguous subnets. What do I mean by contiguous? We go to the 0 subnet, the 1 subnet, the 2 subnet, the 3 subnet, all the way until we fill them all up. So, If we needed 254 hosts, we know we're using that /24. So for the top one, we have 255. But we now need something bigger, something that's got a lot more hosts now. We need something that's going to have double that size because we now have to include this and this. So how do we do that? We just steal a subnet mask and then we cover these two. Now, let's say we want to go from 0 to 1 to 2, and it is 254, not 255, because you can't use the 0 and you can't use the broadcast. So 256 minus 2 is 254. So 0 plus 1 plus 2 plus 3. So let's say we need 1,000 addresses in this subnet. Well, we know we only have 254 with the /24. We know we basically have double that with this. We know that here, but here we gets us to say 750, and here this gets us to roughly 1,000. How do we put 1,000 things in a subnet? What do? Well, we know a /24 is 256 or 254, and we know a /23 is 254 times 2. So what if we need double the size of the /23? We borrow another bit. So that gets us to a, does anybody know what subnet mask is going to cover all 4 of these subnets? What network and mask is going to cover it in both CIDR notation and official decimal notation? /22, meaning 255, 255, 252. This one thing now covers this. So with routing, I can send an address that's called a summary address or an aggregate address. And all the aggregate address is, it's a single address or a single route that encompasses multiple things. And we're going to dive deep into this later. Glad you got it, Bellwinder. A lot of you guys are getting it now. I'm super happy. So that's why we're doing this. So 4 addresses just got reduced to a single address. AWS only lets you have 100 routes. You better get real good at this. 100 routes is nothing. It's like 0. I mean, it's like a 50,000th of what you're going to find in an enterprise. It's that minimal, so you got to get good at this. This is why your IP addressing and your subnet plan becomes so critical. So what I'd like to do, assuming we have time, is show you how to subnet plan your enterprise. On the cloud, off the cloud, hybrid cloud, multi-cloud, so you guys all know exactly what to do. But in order to get there, we've got to get good fundamental understanding of the concept. And if we don't get it here all today, don't worry, we will have a IP addressing design webinar. I'm happy to make it. I just want to know you guys get it. So now, let's do the same thing with these first 4 over here right now. 10.0.0.0 and 10.0.1.0. Can any tell me a summary address that's going to include these first 2 subnets? How do we summarize or aggregate the 10.0.0/24 and the 10.0.1.0 with a single subnet or a single route? What is this going to turn into? Somebody help me here. Pretend I'm bad at math and I could use some guidance. Okay, 10.0.0.0/24, 10.0.1.0/24. How do we summarize them? And are they really any different than the 192.168.0 and .1? Okay, Amrath, we're going to summarize it to a /23. Amrath, now put it down. Write it down what that's going to look for. Eric, it's the same problem with different addresses. Exactly. We're going to give you 2 identical examples, and then we're going to basically boost it up a little bit. So, Eric, good job. You figured it out. So, Chintan, Amrath, type in this box what that whole thing looks like. What is that address? It's 10.0. What? In addition to just the subnet mask. And Eric, you are right. If we do all four, it will be a /22. You're already on the next one. But what's it all looking like? Looks like this. Oh, sorry. /23 for the two of them. And if we want to get all 10.0.0.0 all the way through 10.1.3.0, then it's going to be this. And if we want to go up more and we want to encompass all five, it's going to be the /22. What's that /22 look like? I'll pop it in here for you. Okay, great job. Now, somebody who's good at math. Now I want you to take 10.0.0.0 all the way through 10.0.0.7. How many is that? 1, 2, 3, 4, 5, 6, 7. It's actually 8. Somewhere along the line, we must have cut and pasted something a little funny. Actually, oh, I see what our team did here. Okay, so let's, I can see what our graphics team did here. Bear with me a minute. That's why it's confusing a lot of us. Bear with me while we correct this. I didn't notice this before. Okay, so now how do we summarize 10.0.0/24 all the way to 10.0.7.0/24? What kind of a CIDR mask would this be? How many will support 8 /24s? 8 /24s. What's that all going to look like? Somebody give me a mask for that, and then write it down in CIDR notation. /21. Great, math. Ran. Now, Ran, since you got it, write it down in CIDR notation in the chat window. Start with the subnet and then add the mask, so I know you got it all. Bow Wonder, great job. Same project. Anybody, somebody help me out here. What is the subnet? I see the mask, but what does the subnet actually look like? Derek, you're right. It is going to support 2046 IP addresses. Absolutely the subnet. What's it all looking like? The network includes a network plus a mask. What's the network? That aggregates 10.0.0 all the way to 10.0/21. What's it look like? Is it a 192.168 something? Is it a 172.16 something? Or is it a 10 dot something? Help me out here before we get to the advanced concepts. That's what it's going to look like. Still going to be the 10.0.0. You guys are just giving me the mask. I need this network and the mask. Because that mask could apply to any network. I need the full thing. You don't just use the name of something.com. You need a fully qualified no-name name, www.gocloudcareers.com. You guys are giving me the subnet, the suffix with the subnet mask, but I need the whole thing. So 10.0.0.21, fully qualified domain name, www.gocloudarchitects.com. Thank you. Thanks, Bellwinder, by the way. I just want to make sure everybody gets it. So that's why I'm being super definitive asking questions. Now why the /21? Good question, Eric. Because we're taking a 10.0.0 plus a 10.0.1.0 plus a 10.0.2.0, a 10.0.3.0, a 10.0.4.0, 5.0, 6.0, and 7.0. So we have to combine 8 subnets. 2 to the third. Because we're stealing 3 subnet bits. That's how we got the /21. We borrowed 3 subnet bits. Because we borrowed 3 subnet bits because we're basically taking multiple subnets and combining them. Now, if we were all to make them in a single subnet, it would be a /21. Now, we're actually keeping our subnets still at 254 people. We're just aggregating the information. So what it's really like, Eric, is let's say that you live off of a highway. Let's say I live right off of Highway 95. Now, what a summary route basically is saying, when you come to Mike's house, get on I-95 and get off at exit 118, which is Gatlin Boulevard. The summary route basically teaches you how to get close to me. It's not going to give you my address. It's going to get you close to me. So the summary route is basically, I give you one thing, and it gives you as much intelligence as you need to do to get 99% of the way. And then when you get to 90% of the destination, then it's like you turn on a different GPS that's like, how do you transfer through the world to how do you get to Mike's house? So the summary route is just an aggregate. Now, when you aggregate information, you lose information. It becomes less specific. It's much more specific to say, right side of the room, 192.168.1.0.24 and 192.168.0.0/24. One on one side, one on the other side. No big deal. That's more specific. But if all I have to say is, hey, to get into my house, all you need to know is these 4 addresses, then poof, that's all you need to do. So that's kind of where I'm trying to show you how this works, Eric. I think you got it now. We're aggregating 8. So let's now look at really bad IP addressing schemes. Really bad. I'm going to show you why this is bad. Let's say, for example, you use 10.0.0.0/24 in your network, 10.0.0/2 to your network, 10.0.0.sleeve test network, and 10.0.1.0/24 in the cloud. This is an example of what not to do. Why? Can I now send a single route to the cloud that includes 10.0.0.0, 10.0.1.0, 10.0.2.0, and 10.0.3.0? Can I send this route to the cloud? Is that a feasible route for me to send? Why or why not? I can't use this, by the way. Why can't I use this? Why can't I send this route to the cloud? Does anybody know why this addressing is so bad? Okay, nobody gets this. Is 10.0.1.0 along with 10.0.0.0, 10.0.2.0, and 10.0.3.0 all contained in this 10.0.0/22? Okay, we just did this. 10.0.0.0, 10.0.1.0, 10.0.2.0, and 10.0.3.0 are all encompassed in the same route. So, if I want to tell the cloud, hey, by the way, I have 10.0.0.22, and the cloud also has something in the same place, does anybody see a problem? Like overlapping conflicts here? Yes. So if I were to do something like this, and trust me, I've seen this done many times, and this is bad IP addressing, and when this typically comes from, it's come from a non-networking person that's doing the IP addressing. And you can't use the summary route. So I can still make this work, but now I've got to use these 3 routes over here plus this route. How many routes can you have in your VPC? 100. I've just used 4 of them and I haven't touched anything yet. So we can't do this. This is an example of what not to do. Let's look at it differently. Now, this is properly addressed. We've got the 10.0 subnets in our data center. We've got these 172.16 subnets in the cloud. How many routes does the cloud need to send to the data center to encompass all these? How many routes does the data center need to send to the cloud to accomplish full reachability? One in each direction. Does everybody see the difference between using summarizable addresses and non-summarizable addresses? You guys get me here? Please let me know by typing Cloud Architect if you get it. And if you don't get it, instead of typing Cloud Architect, type I need help. Okay, I'm just letting you guys know there's massive thunder and lightning outside my home right now. I live in Florida. We're in Hurricane Central. We've been getting some massive storms, so I just heard and saw some massive thunder and lightning. I saw the lightning, and within a second, I heard the sound. What that means is the lightning is within 1,080 feet from my house. So if my power were to go out, at least you know I'm not trying to be negative. Hopefully it stays up. That's a possibility. I'm just warning everybody right now. So Nick got it. I love it. You told me with Cloud Architect. Adele didn't get it. That's okay. We're going to do this again. Adele, when we took 10.0.0.0 and 10.0.1.0 and 10.0.2.0 and 10.0.3.0, remember we summarized them into 10.0.0.0/22? Do you remember that, Adele? Yeah, our thunder may go away in 5 minutes, unless it's like yesterday, which took out all my systems for about an hour. Okay, so Adele, you saw how I got here. You did it before. It's the same thing. All we need to do is tell the cloud, hey, by the way, I'm the holder of all these subnets. You guys just did it. Now, let's go over here. You guys just did this. 172.16.0.0, 172.16.1, 172.16.2, and 172.16.3. Didn't you guys all aggregate that into 172.16.0.0.22? Okay, so we'll go back to some more subnetting plans before we get into this intelligent. Alex, I know you're 3/4 of the way there. And now, Amaranth, you don't NAT this. You can't NAT this. This is not a NAT problem. This is a routing problem. This will work. Let's go back to this bad IP addressing scheme. If you don't summarize the routes, and the data center tells the cloud, hey, I have 10.0, 10.2, and 10.3, and the cloud tells the data center, I have 10.0.1, everything's going to work perfectly. Because they're not overlapping IP addresses, they're an overlapping CIDR range. IP addresses are still unique. We don't need NAT. The problem is we can't aggregate or summarize all these routes like we did here in this environment, because if we do this, if we tell the rest of the world, I have this, if we tell the whole world, I have 10.0.0, 10.0.1, 10.0.2, and 10.0.3, but we don't really own 10.0.1 because it's sitting somewhere else, we're going to tell the whole world, reach me for a subnet that doesn't exist. That's the problem. So we need to design our IP addresses in a way that we can send the minimum number of routes. Why do we care about sending the minimum number of routes? We can only do 100. So you need to actually probably be better at your CCIE level IP addressing scheme on the cloud than you would actually in the data center, because they limit you to 100, which is basically 0. Normal enterprise, 7 million routes on the internet they're connecting, and maybe 50,000 internal subnets. That's kind of normal. AWS, 100 max. You've only got 100. So you've got to find ways to aggregate them together. And if your addressing is not good, you can't do it. So all we did is we went from here where we can't summarize. Why can't we summarize? Because this overlaps with this. That's it. This is inside of this. Because this guy, the data center, can't tell the world, I have 10.0.0.0/22. Because he doesn't. The cloud has one of these subnets. He's basically telling the world, I have it. That's kind of like me going to a store and saying, I have everything made by Apple, with the exception of Mac Pros and MacBook Pros, which are sitting to another store. What's going to happen? The whole world's going to come to me for the Apple Mac Pro and MacBook Pro because I told the world I have it. But I don't have those two things. They're sold somewhere else. So if I tell the world I have it, they're going to come to me versus the people that have it. So the whole reason you're doing this is basically just to make sure that you have the best information in as few words. As an architect, you want to take a 10-hour course, make it a 2-hour course, because that's what your executives are going to hear. When it comes to routing tables, the less routes in the routing tables, the less computation on the routers. So they work smoother. Kind of like anything else. If you could read a 1,000-page book that has the information you need in 5 minutes, because it's 5 pages, versus the never-ending story, which is going to take you forever to read, I'm not saying it's not worth reading the never-ending story at all. I've never read it, but people like it. I've never read a novel in my life, but I'll tell you, we typically 2 or 3 books a week that improve my performance in some way, shape, or form. But I don't read nonfiction. I don't read fiction. I just don't have time for it. But again, it's good. So what I'm saying here is design your systems and your communication paths ahead of time. So let's go back to this example now. Does everybody see how right here, all these routes are made by the same summary address that you guys made previously? And all these routes are made by the same summary address? And that's why we only need to send one route in each direction? So we're going to do it this way. I'm going to give you a little more, then we're going to break out the whiteboard session. And on the whiteboards, we're going to just start working it through one at a time. We'll design systems. I'll make all you guys give me some answers and we'll get there. So going back to this. Here's some guidelines that I'm going to give you. If you're dealing with router loopbacks, you're using the /32. What does the /32 for router loopback look like? It looks like this. That's a loopback address on a router. It's a /32. Best way to identify a router, come up with a unique loopback. That's typically what you're doing. So after that, WAN link, /30. Why /30 for a WAN link? You've got 2 hosts. The router on one side, the router on the other side. What is a WAN link? It's going to be a /30. What does that look like? It's going to look like 1.0.0.0/30. Meaning the usable IP addresses are going to be .1 and .2. My screen has gone? Yeah, it's intentional, Alex. I wanted to get in front of you guys to talk to you. That's why I got out of this, and I'm using the chat box. So for a /30, it's going to be 255.255.255.252. So a WAN link is going to look like this. And a LAN link, just because the /28 is the smallest you can use in the cloud, don't use it. I promise you, what's going to happen in the cloud when you use a /28, which only gives you 11 addresses, you're going to run out of them. Auto-scaling is going to kick in. You're going to need more servers. And after you kick in with more servers, we're going to be in trouble. Why are we going to be in trouble? We don't have enough IP addresses, so it's not going to scale. So /24 for LAN, /30 for WAN, and oh, by the way, /32 for loopbacks. If you can remember that, then you completely understand. Derek, I intentionally stopped sharing my screen. I want us to have more of a conversation now versus people just staring at a blank screen with a PowerPoint slide. We'll work out things more. When it's appropriate, I'll go back and start sharing my screen again. I intentionally unshared it. So now that you know, let's talk about mapping it together. Let's have a little fun with this. Let's work on some whiteboard sessions. So let's do some whiteboarding. And what's it going to look like? We'll deal with it here. So now we're going to have some whiteboarding sessions. Now, in this whiteboarding session, I want you to think about the following. Truly maximize the addressable use space that you have and minimize the number of routes. So let's take a data center and a multi-cloud. Let's say we've got our data center. Let's say we've got AWS over here. Let's say we've got GCP over here. Let's say we've got direct connections to one on AWS and another one and another direct connection to GCP. And we're using multi-cloud because we don't trust one cloud provider. We want some redundancy. We're going to have a primary connection and a backup direct connection because we're not using the internet. Performance is too slow for us. So let's say we have this. Now, let's look about how elegantly we can do this. What if, for example, we use the 192.168.0.0/16 address space in our data center? By the way, this is good. I'm showing you how to do it the right way. Now, let's assume in AWS we use this 172.16.0.0. Amaranth, you heard it right. /24 for LAN, /30 for WAN, and /32 for loopback. You got it. Now, let's say over here in the Google side, we use the CIDR range of 10.0.0.0/16. Now, inside of GCP, we can create as many subnets that we want in this 10 range, which might be a 10.0.1.1.0. It might be a 10.0.2.0. You guys see where I'm coming from? It could be a 10. It could be a 10.1.0.0. So all these subnets are constrained in this /16. But assume they are. But realistically speaking, from a routing perspective, if you know that the 192.168 subnets are all in the data center, and you know that the 172.16 subnets, every last one of them is in AWS, and you know that the 10.0.0/16 is sitting in Google, how many subnets does the data center need to know to be able to communicate with these two people? With the cloud, AWS and GCP, how many subnets need to be in its routing table from AWS and GCP? Well, let's go back to Mike's example. Let's go back to, let's say Alonzo's coming to my house. Iran, you got it, 2 routes, that's all I need to know. So the way these summary routes are going to work is, I want Alonzo to come to my house, want him to play with one of the toys I have in the house. I like Alonzo, I know Alonzo well, he and I like similar kind of toys. So if I invited Alonzo to play with some of my toys in my house that he would enjoy playing with, I might just give him a summary that says, get to Gatlin Boulevard. Or better yet, I might give him a summary route that gets him to the security guard at the front of my community that checks IDs. That's the summary route. Now, once he gets to my community and he gives his driver's license to the security guard, the driver's license is going to say, hey, to get to Mike's house, make a left, make a right, and here's his address. That's what routing is. That's optimal routing. Optimal routing is this. I know to get to AWS to reach the 172.16 subnets. Now, once I'm there, AWS has its own router that's going to know how to take me to which subnet in my VPC. Because it's like the security guard that tells Alonzo once he gets to my community, make a left, make a right, like a left or right, and stop here. the house with the cat out front that's always meowing, and the cat out front that always says hello, that's probably Mike's house. Mike loves his cat. I love my cat. So, that's typically the way these things work. By comparison, let's say Arun's over at Google, and I want to go to Arun's house. I know to get to basically his province in Canada where he's at. Now, once I get to the province in Canada, I got to go through customs, and let's say customs gives me directions to Arun's house. Again, that's what's going on. So we only need 2 subnets from this perspective. Does everybody see how only knowing 2 versus all the subnets constrained inside of these things could minimize the overhead of the routing table? Does that make sense to everybody? You guys get this? If you can let me know by letting me know, yes, I get it, or no, I don't. Because if you don't, I'll try explaining it a different way. And if you guys get it, I'm going to move on to more advanced concepts. Well, this thunder is really good. Ryan, you got it? That's good. Guys are quiet. Are you awake? Alex, you got it? Kwasi, good job. Derek, okay. Nick, good. Arun, good job. Shapur, wow, I'm feeling really good. I drew 4 links, Amrath, because I wasn't actually including the subnets on the WAN. I was just including what you needed to know from AWS. Alonzo, it's clicking. Great job. Okay, so let's move these numbers around while we're still using good IP addressing schemes. And we just moved our numbers around for argument's sake. If you're at the data center, now I know to reach AWS, I need a route to 192.168.0.0/16. And I know to reach the GCP at 172.16.0.16. Now in this GPC VPC, we may have this. We may have a 172.16.1.0. We may have a 172.16.2.0. We may have a 172.16.254.0. We could have all of this stuff. So that's our /16. We get to manipulate this octet, which is networks, and this octet, which is subnet banks. Sometimes I'm drawing things on the blank, so if I'm drawing things on the fly, if I occasionally make a little math error, you can tell me. I've done this for 28 years, but in the middle of looking at comments, we can always make math errors. So 172.168.3.16/248 with a 248, which is /27. So I could have any or all of these subnets here, but all I need to know is to get to Arun, who's like Google, get to Arun's house, and once I'm in Arun's house has a router that's going to give me the subnets to reach every destination I have. So that's realistically speaking what's going on here. Did you guys get it this time? Most of you got it last time. This again is the right way to do it. Now let's say this. Let's say we designed this like a nightmare. I've seen this all the time. These are the people that don't have a network background but are designing subnets. And they're going to have things and they're going to look like, for example, let's say you have the 10.1. or the 10.0.1.0, and then we have a 10.0.9.0. Let's assume these are all /24s. And let's say we have a 10.0.8.0. let's say we have a 10.0.54.0, and these are all /24s. Now let's say, in GCP, we use the same CIDR range, but we didn't use overlapping addresses. We're just in the same CIDR range. So here we've got a 10.0.2.0/24 and a 10.0.3.0 slash, my typing is pretty ugly. I gotta tell you, my typing is terrible today. And let's say we've got over here a 10.0.53.0/24. And let's say we were really bad at this. And we, for example, we had another 10.0.0.0/16. And let's say you had this, and this same one doesn't have overlapping addresses, but it's got 10.0.0.4.0 and 10.0/24, and you've got a 10.0.5.0/24, and then you've got a 10.0.56.0/24. I'm going to tell you right now, all your communication will work because there's no overlapping IP addresses. I'm also going to tell you, I've seen this 1,000 times in my life. This always happens when a non-network person designs the network. Always. Now, what does this look like to you? Now, in this data center, can AWS send me a 10.0.0/16? Can Google send me a 10.0.0/16? Can Google say, I own every single subnet from 10.0.0/16 all the way to 10.0.255.255? Can AWS say, I have everything from 10.0.0 all the way to 10.0.255.255? Can my data center say, hey everybody, I own 10.0.0/16? Can I do that, or do I have a problem? Because everybody's using the same aggregate range. So the only thing I can do here is now send every signal subnet everywhere to everybody. Now if I do this, and we've done nothing. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. So basically speaking, we've now used up 8 and 5 is 13 addresses. And we can't now configure aggregate routes. So we've used 13 subnets just for this. Now let's go look at our links. We need a subnet for this. We need a subnet for this. We need a subnet for this link. And we need a subnet for this link. So now we've used 17 subnets for nothing, literally nothing. We haven't addressed remote users. We haven't addressed firewalls. We haven't addressed IDS, IPS systems. We haven't addressed DMZs. We haven't addressed anything. We've already used up 1/5 of all our potential routes on the cloud doing nothing. That's why your addressing schemes is so important. A good addressing scheme will make you traffic engineer through your network. A bad addressing scheme will keep you from traffic engineering. A good addressing scheme will let you determine things with BGP, how to get from point A to point B. A bad addressing scheme will keep that from happening. So IP addressing is really, really, really important. That important. So that's why I want you to understand this. I will tell you, I have been working in networking since 1993. I've been a CCIE since 2000. 80% of all networking problems that I've ever dealt with are when PC or our systems admin people design IP addressing schemes because they don't understand the IP addressing and they don't understand the routing. So when this is something I've been debating about, talking about the community. I see these course providers that have never worked in networking in their entire life, and they're telling the world, I've got an advanced networking course, and you can learn networking from me. And they've never worked in networking in their entire life. They're going to teach you how to create these disasters. How do I know? In 25 years, I have done more fixing these disasters than any other design. So when you take a course, whether it's with me, whether it's with someone else, go to their LinkedIn profile. If they have a networking course and they're not a network engineer and they've never worked in networking, don't buy their course. It's going to confuse you. That's why I don't have any DevOps courses. Why? Because I'm not a DevOps engineer. Why do we have network architect and cloud architect and cloud security? Because they're the three things I'm an expert on. Do I have somebody that's got 17 Linux certifications that's worked at Red Hat since I coached them years ago making a Linux for Cloud Architects course? Yes, I'm not doing it. This person was senior at Red Hat because they're experts at it. When it comes to DevOps, I've got 2 DevOps people that have spent more than a decade each building a DevOps course. DevOps is not architecture, but it's still good. So when you get something or you get training, look at the source of the offers. What have these people actually truly done in their career? If they're not networking people, don't buy their networking course. If they're not a security people, meaning working as a security architect with a CISSP or a CEH, don't buy their advanced security because they don't know security. So I just want to make sure that we all get access to the right information at the time. So I don't teach what I'm not an expert in because it's not fair to my customers. But 90% of the e-course providers that are there do. So I'm just saying that if you see a networking training, and I encourage you to get networking training, I'm happy to provide it. You can also get it from Cisco Press. You can get it from Juniper Press. We are the people that come from it. I spent a decade at Cisco and teaching systems engineers at Cisco. So whatever the case is, but when you're getting this training, make sure for your career you get it from reliable sources, whatever they may be. Same thing, I don't go to a dermatologist, which is a skincare doctor, to deal with my heart. Thankfully my heart's good, knock on wood, but I wouldn't do so. I wouldn't go to a cardiologist to deal with a problem with my feet. And I wouldn't go to a non-network person to make me network training. And I wouldn't go to a programmer to teach me medicine. It's just who I am. So these are just my recommendations for you. But you see what we did here. We used a good addressing scheme and a bad addressing scheme. So let's work these through. Now let's come up with an environment. I want you to tell me how many subnets are going to be needed. So now let's say we've got a data center. Actually, let's do this. Let's say we've got a switch. The switch has 16 VLANs on it. Now, what is the VLAN? The VLAN is when you virtualize a switch. So realistically speaking, you chop a switch into 16 switches. So let's say you've got 16 VLANs in one switch, a router over here, which is a layer 3 device. Got a link. We're going to say this is a layer 3 switch. What do I mean by that? It's going to be a switch/router. So let's make the switch on the other end a layer 3 switch. And let's add a WAN link from the router in the center to this next switch. Can anybody tell me how many subnets I need right now? At minimum? Okay, so every VLAN is a broadcast domain, which means it's constrained, meaning other users can't see each other's users that are in different VLANs because each VLAN must be on a different subnet. So let's go back to this link. I've got a layer 3 switch, which is a switch with a router in there. So not 16 ports, 16 switches. Okay, so Chin, you're pretty new, so let's do this. Let's say we've got a switch. Let's say the switch has 100 ports. So we're going to do a VLAN example for you here. Let's say in the VLAN, we decided to constrain it, and let's say we put ports 0, Nick, you're close, but you're still missing 2 subnets. So let's say we have the accounting people here. Let's say we have the finance people here. Let's say we've got dev over here. Let's say we've got security over here. So, Chintin, you know how virtualization enables you to take a bare metal server, attach a hypervisor, and then with that hypervisor chop that physical server into multiple logical servers? Now, when we're dealing with a VLAN, all we're doing is we're taking a switch and we're chopping it out to additional switches. So let's say you've got additional logical switches. So let's say you've got 100 ports in the switch. You might put ports 1 through 24 in the accounting VLAN, 25 to 49 in the finance VLAN, 50 to 74 in the dev VLAN, and 75 to 99 sitting inside of the security VLAN. I hope I made that clear for you. So each VLAN is going to be in a different subnet. So Christian, that's what I meant by that. So somebody was really close when I said how many VLANs, how many subnets. 16, each VLAN needs to be on a different subnet. So 16 VLANs, now they're separated by a router. If they were separated by a switch, it would be different. They're separated by a router. What do you need when you connect a router to a router? You need another subnet, which is going to be S/30. Now you need a subnet connect this switch to the router, but you need another subnet because every interface, like arm up, arm down, what is that? They used to have a song, Walk Like an Egyptian by the, was it the Go-Go's or was it was by one of those bands years ago where they had arm moving in funny directions? Well, a router's like an arm. Got an arm up, an arm down, an arm sideways, an arm this direction. And each interface needs a second one. So Derek Houston, 16 for each switch plus 2 for the routers. Beautiful, you got it. Now, let's change this. I want you guys to get it. Now let's say we've got 48 VLANs on each side. It's common. I've seen switches with 100 VLANs on them. They were basically WAN interconnect switches. So everything was on a separate subnet. There's the Bangles. That's right, Alex. Yes. I think they were the same people that made the 6 o'clock already in the middle of a dream. What was that? Manic Monday. Wish it was Sunday. That's my fun day. That kind of thing, Alex. Now you got me on the Bangles. So Alex, 96 plus. What's missing? You're there. 48 for each switch, but we got to connect into the router. So 48 plus 48 is 96. Class, you got it. 1 for each WAN link. Congratulations, you got it. We need 98 subnets for this. Good job. Now let's do this. Let's give you a bit of a dose of reality in a lot of network environments. Let's say you've got a big router, and let's say you've got New York, and Y office. Let's say San Francisco. Let's say, you know what, let's have some fun. Let's say Montego Bay. Pick a city in Jamaica. You know what? Let's pick 2 other cities we have a tremendous number of students in. Let's say we pick Bangalore. All right, we're just going to keep it to 4 because that's all the space that I have. Probably should have said Lagos. Probably got more people in Lagos than San Francisco. So let's say Lagos. So now we've got, a WAN link. Now, let's say in New York, we've got a campus with 25,000 people and 100 subnets, which is nothing, literally nothing. So let's say we've got 100 subnets here. Let's say we've got a smaller office in Lagos, Nigeria. Let's say we've got 50 subnets here. let's say Ryan, who's usually who's in Montego Bay, and Ian and Malik. Some of my students decided to go to Jamaica and build a data center out there, and there's 25, well actually some of them are already there, and 25 subnets here. And let's say we've got a huge R&D facility in Bangalore, and over here we've got 1,000 subnets because we've got lots of data centers. Now, let's say that we've got WAN links going from here to here. Oops. Okay, and now let's say this is the main data center. We're not doing .1q tagging or trunking here. We're dealing with layer 3. You can't use trunking when you're dealing with routers. Well, you could, but you wouldn't. And if you want, I'll show you guys the difference between trunking and routing. In order to have the same VLAN on 2 switches, you'd have to trunk, but that would violate a lot of the security and things that we want to do, so we're not going to do that. There's a time and a place to do that, though. So this is traditional setups. Let's say we've got 500 VLANs in the data center. Okay, somebody tell me the minimum number of subnets required. And actually, let's put a loopback address on every single router. So this is going to be 1.1.1.1, and this router's loopback address is going to be 2.2.2.2, because you're always going to have a logical address in your router. 3.3.3.3, which is a pretty common way to do it, and that way people identify things. And let's say this is 4.4.4.4.4, and let's say your data center's loopback address on its router is 5.5.5.5. Theo, great having you. Watch the rest later. We'll see you in class on Friday. Great to have you here today. So, how many subnets here? William Wallace. Okay, so what did you do? You added the 10,000 plus the 25 plus the 50 plus the 100 plus the 500. So somebody do that, and then we're going to add the rest of the subnets that everybody's forgotten about. So just for the VLANs, we need 10,000 plus 25 plus 50 plus 100 plus 500. So for the VLANs themselves, we need 10,675 subnets. Again, this is nothing in a real enterprise. Now, what other subnets do we need? Well, every loopback needs to be on its own subnet. So we're going to add 4 more, or 5 more. So that's 5. So it's 10,675 plus 5, but we're not done yet. We need a subnet for this link, this link, this link, and this link. So add 4 more. So now we need 10,684 subnets. Now, let's pretend you want to send this to the cloud. You have a problem? You got a huge problem. They only let you give them 100. So, because of that, William, you actually did fine. I think your error was that you didn't see that Bangalore was 10,000 subnets and you had it as 1,000. So, this is how fast these networks grow. Now, can you summarize this and send an aggregate route to AWS? I don't know. If you addressed it intelligently, perfect. You'd be in great shape. Everything would be wonderful. But if you addressed it wrong, you couldn't summarize these things, and you're going to have these things. So, you want to connect to the cloud, you only have 100 routes. Well, you got to get there. So, everybody got that, and why? So I'd like a volunteer from the audience. I'm going to have you do a subnet and a reverse subnet of a subnet. Anybody want to take a stab at this? I mean, I'm happy to keep babbling, but I'm always in a position where I'm happy to keep babbling all day long. I'm a babbler, it's fine by me. But, you know, I'd like to get you guys engaged, involved, have some good time, learn lots of lessons. So anybody in the audience want to be a volunteer for the next lesson? Okay, I'm waiting to see if anybody's interested. Arun, good job. I'll have you do it. I always love your motivation. It's fantastic, and to some degree it's infectious to others, which is fantastic. So let's do this, Arun. And then Alex, you got it next. I want to make this an interactive, lively experience. I want you guys to become experts. Alonzo, that's okay. You can do it another day. Today, you don't have to be the victim. Another time we'll make you one. And then Derek, awesome. So, okay, somebody, here's what I need you guys to do. Let's start with this, 192.168. And then Amrath, sure, why not? Let's have some fun. So let's say we've got this /16. I need you to, here's what I want you to do, Arun. I need you to, as efficiently as possible, break this down into another subnet, and then break that subnet down to accommodate 10 WAN links. So we're not, because we don't, if we use the 192.168.0.0/16 and we put it on a single WAN link, we've used up all 65,000 potential addresses. So I want you to efficiently break this down into something for which we can have a link that you can break down into 10 subnets. And because you're going first, I'm going to help you. Let's say we break this down into a /24. So we're going to add a 192.168.0.0/16. And I'm going to break it down into a smaller subnet for you. And then I want you to break that subnet down into other subnets. I'm going to give you help. So the reason I picked it this way is, you know, with the 192.168.0.0/24, you know, you still have access to the 192.168.1.0 network. You'll have access to the 192.168.3.0 network. And truth be told, you'll have access to still all those addresses .254.0.0. Again, you see where I'm coming from is you get a lot of it. So you can break it down and still save. So I want you to take this big Class B address, basically, that we've given you, Arun, and I broke it down into a /24, which is the equivalent of a Class C. And I want you to give me 10 subnets that each have 2 usable links for WAN links, as efficiently as possible. Start at the 0 subnet and work up 10. So Arun, I'll even help you with the first subnet, 192.168.0.0/30. Now from there, I want you to tell me where the subnet begins, the usable addresses, and the broadcast address, and then after that, I want you to give me the next 9 subnets. Arun, you with me? If you're there and you need to take a break, or let me know. It's also hard for me to tell because there's like this 60 to 90 second delay sometimes. Okay, Arun, I'll give you a few more seconds, and if not, I will move on to the next person. Ten, nine. Okay, Arun, I haven't heard from you. Maybe you've got a little internet outage or something like that. So Alex, do you want to break down the 192.168? And then Kwasi, you guys can answer as well. So I need the first 10 subnets. But I'm going to give each of you guys a chance for a minute. So, okay, so if I need to efficiently create 10 subnets for WAN links that only use 2 IP addresses each, what kind of a subnet do I need? I need a /30. So if I take the 192.168, where do those addresses begin and end? So this particular subnet, 192.168.0.0, starts from 192.168.0.0 to 192.168.255.255.255. That's the broadcast address. Can anybody tell me 2 to the 16th minus 2 how many addresses that is? It's a pretty big number. Now, if we put that on one interface, we can't use them anywhere else because each interface needs a different subnet. So Nick, you got it. Christian, you love it. Or Nick, love, you got it. Christian, you got it. So if I take this, which gives me 65,000 addresses, and I break it down into this, which gives me 254 addresses, do I need 254 addresses for a WAN link? No. I need 2. So I pick /30s. So I now subnetted this into a /30. So what are these subnets going to look like? Let's work our way up. 192.168.0.0/30. The next subnet will be 192.168.0.4/30. The next one will be 192.168.0.8/30. The next one will be 192.168.0.12/30. Thanks, Ron. The next one will be 192.168.0/16/30. Does anybody see the pattern here? Anybody know why this miraculously is going up by 4 every time? I wonder, I'm sure you see this pattern by now. I know you. 192.168.0.32 /30. So this is how one single /24 would break down. They're going up 4 each time. Why 4? We borrowed 2 subnet bits, right? 2 to the second. 2 times 2 equals 4. Now when we're dealing with addresses, we're pulling out 2. Why? Why are we stealing these 2 addresses? Because the 192.168.0.0/30 is the subnet. The 192.168.0.1 is usable. The 192.168.0.2 is usable. The 192.168.0.3 is a broadcast. Guess what? We're now on the new subnet because they increment by 4. 192.168.0.4 is the network. 192.168.5 and .6 are usable. 192.168.0.7 is broadcast. Does that make sense to everybody? Guys all with me? I know this is some pretty tough material. There's nothing more dry than subnetting math. Adele, I see you got it. Derek, you got it. Arun, looks like you got it. Kwasi, you got it. Alex, Adele, I'm awfully happy. If you guys are having fun, Let's signal the algorithm and let me know you're awake, alert, and oriented by typing Cloud Architect in the window. And if you have the ability to leave a like, it helps the algorithm tell people what we're doing is useful. So please add that if you're comfortable. No obligation, of course. Okay, Arun. That's an actually exceptionally good question. How did we go to the /30? What did I do? I didn't want you to start at the 192.168.0.0/16. Why? Because I wanted to be really good. Alex, let me know if you guys are awake. Tell them type Cloud Architect while I answer Arun's question. So, I didn't want us to use the /16 because we would have burned 65,000 IP addresses in a single thing. So I broke it down into a /24. Why? Because it's a very manageable thing to look at. And then I took the /24, which gives us 254 addresses, and it says, wow, that would be crazy to actually use this, specifically speaking, for a single set of IP addresses. So let's break it down into something further. So I broke it down into a /30 because they're WAN links. And on WAN links, you only need one IP address on both sides of the link. That's why we used it. So that's exactly why we started with one big address. We chopped it down into smaller addresses. And after we chopped it down into smaller addresses, we further subnetted for maximum IP efficiency. Remember, there's a shortage of IP addresses, so when we have them, we've got to be good stewards of them. We have to protect what's going on in the network and take care of absolutely one of these things. So, does everybody get this? If everybody gets this, does anybody want to take a stab at another one? When it comes to your VPC quasi, AWS only allows you to do a /28, but there's a difference between WAN connection and your VPC. But it's true, the smallest subnet you can put inside your VPC is actually a /28. Balwinder, great. And then Alex, I want you to do it. Balwinder, you seem to be getting this super fast, so we'll give Alex one more shot. Alex is doing great. Alex has learned so much so fast. I'm super proud of him. And I know exactly how hard he tries and the number of things that he goes through every day, just like I do. So, let's do this, Balwinder. I'm going to give you 192.168.1.0. But we're going to give you a different kind of network problem. Instead of having a point-to-point WAN link, what we're going to do is this. We're going to create a link. And on this link, what we're going to create is going to be a switch. And we're going to connect a router, 3 routers to the switch. All on the same subnet. So for those of you guys that are not used to old school, this is what an Ethernet LAN looks like. So we're going to call this a LAN. I'm just going to call it a VLAN, make life easy. Now let's say you've got 3 routers in here, all on the same subnet. Okay, so this is a LAN link. And we're going to have a router, and the switch is a layer 3 device, so consider this to also be a router. So we're going to have 4 devices on this connection now, instead of 3. This is all going to be in a VLAN. So Balwinder, now we need 4 host addresses per WAN link, because we're using multiplay connections, we're using Ethernet, and we have 4 routers all plugged into the same VLAN. So now we can't get away with 2 IP addresses, Balwinder. We need to come up with 4 per subnet. So I still want the first few subnets, but now you've got bigger subnets than the last person. So we can still take our 192.168/16 and break it down into this 192.168.1.0/24. But now we need a subnet that can handle 4 versus 2. So before we were using a /30, how many addresses did a /30 give us? 2 usable addresses, 4 max. Can't do that, we need 4. So we have to go up 1. We're going to move to a /20. 29. So by moving to a /29, we're going to have a 192.168.1.0/29. So /29 is different than a /30. A /30 was 2 to the second minus 2, right? /29 is 2 to the 3 minus 2. Why did we pick a /29? Because we need 4 host addresses. 2 to the third gives us 8, minus 2 gives us 6. So the smallest subnet we could use for each one of these things is going to be a /29. So Balwinder, give me the first subnet, the second subnet, the third subnet, the fourth subnet, the fifth subnet, and let's work our way up from this first one that I already gave you. So the first subnet begins at 192.168.1.0. Yes, there are 6 usable addresses. Excellent, Balwinder. So tell me where the first subnet begins. I'll actually tell you the first one. 192.168.1.0 is the network. 192.168.1.7 is going to be the broadcast. And every address in between the .0 and .7 is usable. So Balwinder, now that you know that, which I knew you probably knew before because you're pretty good at math, now what I'd like you to do is I'd like you to give me the first 8 subnets. You can just type them in the chat box. No, you were right. You had 8 total with 6 usable. You did great with that. So now just help me find the next couple of subnets that are all going to increment by 2 to the third. Two to the third. That's going to be the number that you're going to do each time. So anybody want to work with me a little bit on that and find it? If the first one goes from 0 to 7, where's the next one, Balwinder? Okay, well, let's look at it this way. 192.168.1, 2 to the third, .8, /29. I'll give Balwinder a minute to get to the next one. Amaranth, that's actually technically correct. Ian, that's great. Good job. I'm giving you a minute, Balwinder. Okay, so I'm going to add one more Balwinder and then you do the next one up. So let's do the next. So let's add the next subnet. 192.168.1.16 /29. Do the next one, Balwinder. Remember my subnet math. 2 to the third, 2 to the third, 2 to the third. And why are we not subtracting the 2 here? Because we need to calculate everything, including the subnet and the broadcast. We subtract 2 to find the usable addresses. Eric, yes. The next one is going to be a .24. Good job, Eric. So what's everybody think the next one going up is going to be? No, it's a little quiet, but you guys are doing great, so I want you guys to work the problem through. I want this to be part of you. I wake up in the middle of 32. Good job, Alex. I think routes and routing tables in the middle of dreams sometimes. I think IP addressing plans sometimes. Good job, Balwinder. It's going to be .30. Actually, it's going to be 24 plus 8, which is going to be 32. Remember, Balwinder, it's 2 to the third for the total number of 2 to the third for the subnets, and it's 2 to the third minus 2. You're always subtracting 2 because you're subtracting out the network and the broadcast. So they're going to increment by 8 every time, Balwinder. Next one's going to look like this. There you go, Balwinder. Now the one after the .40, what's that going to be? Oh, there. You mean they have a pill for waking up and thinking about subnets and network architectures and design things? They probably do. I think it's also the product of literally, walking into organizations that have never done anything like this before that says, hey, by the way, we want to do IPTV, and it's 2001, and we only have 7 megs of bandwidth, but we need to stream 2 channels. And if it takes more than a quarter of a second to change channels, people are going to be upset. So, good job, Balwinder. You had the 168.1.48 because somebody else put it there. And then you instantly, before anybody had a chance, went there, Balwinder, and you did 192.168.1.56. You got it, /29, Balwinder. And then the next one will be 192.168.1.56 plus 8 is 64/29. And even for me, a non-math guy, a verbal guy, 1.72/29. Great job. Wonderful. I'm super proud. Great job, Balwinder. Great job, Nick. Yeah, Derek, I've had so many networking things throughout my career. You have no idea some of the things that go through my head. And I get calls from somebody, and they're like, hey, Mike, what do you think about this? And at 3 o'clock in the morning, I'm figuring out where there's a problem with their RSVP signaling and their MPLS path. It's just part of life. I've been involved in this stuff for so long. And actually, Arun, good job. You're actually correct. We needed 4. And we couldn't do that with a /30 because that only gives us 2 because we lose the network and the broadcast. So good job. Okay, nice job with that. So here, let's create a WAN. Let's say we've got Palm Beach, Florida. Closest location to me. Let's say I'm here. Let's say my COO is in Tampa. Let's say my close friend who helps me with graphics is living in Texas. Let's say another warrior buddy of mine who also helps me with some stuff like setting up VMware ESXi servers is actually sitting in London. And because of this, I decided that there's going to be so much communication that I'm going to buy a private line between all of our locations. And that way everybody can access my systems. So Chris and I are going to be speaking through a private line. Alonzo and I are going to be speaking via private line. Let's say Ian and I are going to be speaking by a private line. And let's say each one of these guys has an Ethernet where their computers are at. St. Pete, not Tampa, same place, Chris. That's why they call it Tampa St. Petersburg for people like me that can never understand. They just add the two cities in the same place. Okay, so we got a LAN. Let's spell it properly. So I've got a LAN associated. What's on the LAN? That's where the people plug in their computers. And thankfully, most people are not like me, where they don't have a whole bunch of servers, Xeon servers in their house, and GPUs doing stuff throughout their house, and about 50,000 BTUs sitting in a room that's 100 square feet to cool computers off. So let's say you've got a normal house, not my cool location. So, and let's say on my house you've got 5 LANs. I think I have a little more than 5 LANs, but let's just say it's 5. Okay, so there's 5 LANs at my house. There's a LAN in the Tampa office, a LAN in the Tampa office, and then, okay, so does anybody remember the subnet size that I told you to use for the LAN? The one that's going to give you enough space to add servers or auto scaling? I told you to use a slash something. Does everybody remember what that is? Okay, now Balwinder, the /28 is the smallest you can use in AWS. But I told you never to use the /28 and to always use the /24 as your smallest subnet. That is my recommendation after 25 years of networking. Why? A /28 gives you the following. If you're not in AWS, it's 2 to the 4th minus 2, which is 16 minus 4. If you're in any of these cloud providers, they steal a whole bunch of IP addresses for whatever research purposes they desire to use. So you can't use them. So with AWS, you can't use the first one, and you can't use the last one. So with the /28, which is the smallest, you only get 11 addresses. 11 subnets addresses on a subnet is 0. Why? Because you're going to need one for the router. That's automatically going to use one. Then you're going to need one on a load balancer and one on a server. That's 3 just there. But if you've got 2 servers and the load balancers scale up and the servers scale up and you've got at least a web app and database tier, you can easily run out of it. So the smallest on the LAN interface you should use is, typically speaking, the /24. Because that gives you basically 240 addresses, or 254 addresses. So you're going to have a /24 here, a /24. I don't know. Might be quicker to type than it is to actually try and cut and paste the way I'm doing it. And then let's say that all these LANs on my systems are /24s. Now we've got a WAN link. What's the best subnet for a WAN link, everybody? How many addresses do I need for one interface on my house to talk to one interface in Chris's house? 2 people having a conversation. How many IP addresses do 2 people need having a conversation? If each person has its own IP address. Anybody? Or am I just dealing with a massive delay, which is quite possible, over the wide area network? Okay, so let's do this. We got a WAN link. What do we use for WAN links? /30. Good job. /30. So this link's going to be a /30. This link's going to be a /30. This link's going to be a /30. So now let's think about how we can do this in our network. let's see. Let's say we were given the 172.16.0.0/16, that this is our CIDR range. And I think there's a pretty big delay between the time I actually type something and the time you guys can hear me right now. So it feels like by the time I ask a question and the time you guys are responding is over 2 minutes. So if I ask something a couple times, I wasn't aware of this delay. Now you know why. So let's say that we have this. If we put this 172.16.0.0/16 on a single link, what happens? We can put it on this WAN link and we've got no more IP addresses. We just wasted the 65,000. So we can't do that. Now, realistically speaking, let's say this is our own entity. And we're not going to do any route summarization on our own entity. Of course we would, but we're not. But let's just say to keep this very easily, what could we do? Well, the first thing we can do is we need to come up with something for the WAN links. So I'm going to give myself plenty of room for the WAN links. I'm going to give my WAN links, I'm going to take and consume the 172.16.0.0, and I'm going to say /23. Why am I going to pick that huge number? Because it's going to give me a lot of WAN links. Do you want to know how many WAN links it's going to give me? I can tell you this. 0 to 4, 4 to 8, 8 to 16, 16 to 24, 24 to 32, all the way to 256 times 2. And then basically what I'm going to say is for the first WAN link, I'm going to do a 172.16.0.0/30. This is going to be, I'm going to pop this over here. That's going to be used over here. Now this next one is going to get another link that's going to look very close. The next one down is going to get the 172.16.0.0 or 0.4/30. So I'm going to pop this over here. Then let's say I'll go here for the next /30. I'm going to do the next one, which is going to be a 172.16.0.8/30. Now let's say I'm going to take a big jump because I want to be able to aggregate my things. So for example, let's say we decide to start 172.16.0.0 or 0.16. I'll show this. So let's say we decide to use this for our headquarters here. So let's do 16. Let's do this. So we've already used 0 and 1. Let's go all the way up to 16. I'm going to show you why. So we need 10 subnets over here, right? So let's say we do the 172.16.16.0, and then we do a .17.0, and then we do a 172.16.18.0, and then we do a 172.16.19.0, and then we do a 172.16.20.0, and then we do a 172.16.21.0, and a 172.16.22.0, and a 172.16.23.0, and a 172.16.24.0. We needed 10 of these, remember? And a 172.16.25.0, and a 172.16.26.0. These are the subnets we need for our Palm Beach data center. These. These are the subnets that we're going to stick in Palm Beach. Let's get rid of these little subnets because it's hard for you to see what I'm doing here math-wise. Bear with me. Let's say I've got all these subnets sitting over here. Can all these subnets potentially be aggregated into something that all the other people could look at, for example, so they don't have to see all these 10 subnets? Are they contiguous, meaning one right after the other? 16, 17, 18, 19, 20, 21, 22, 23, 24. That is 16. So if we took a subnet that went from 16 to 32, would that encompass all of these and leave us room to add 6 more subnets? Of course it would. So how would we aggregate or supernet, which is the exact opposite of subnet, these routes? Well, what could that look like? What could all this mess be summarized as? 172.16. Now we've got 16 all the way to 31, or 16 all the way to, which is gonna, so 16 to 31, so 16, 17, 18, 19, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 16 addresses. So where do you think the next subnet will begin? It'll begin with .32. But what kind of a subnet gives us 16 potential subnets that we can put in here? We could do a 172.16.16 dot what? .0 slash, okay, a slash 24 is one subnet, a slash 23 is 2 subnets, a slash 22 is 4 subnets, a slash 21 is 8 subnets, and a slash 20 is 16 subnets. So what would this look like? Slash 20, what's that mask going to look like? 255.240, I want to make sure I got that right, 192 plus 64 plus 32 plus 8, yep, got it right, and slash dot 0. So does everybody see what we did here? We put all these 10 subnets here, as highlighted. We aggregated it in the same subnet over here. You guys got it, slash 20. You guys are doing great. I'm so happy. Literally, you have no idea how happy I am. So we aggregated it all, and guess what? We still have space, and this is why I picked something also big, to add a slash 27, a slash 28, a slash 29, and a slash 30. Why? And even a slash 31 subnet. Why did we do this? I want you to have room to grow, because no matter how much you think you have, it's never enough. Probably would have given myself more room to grow in the data center, like a lot more. But I'm just picking easy math numbers here. Now, how many subnets do we need for everybody's LAN? Just one. That's it. So let's say we do 192.168.0.32 slash, I'm sorry, dot 32.0 slash 24. We got it. I was not even mean to do that. And now let's say for the next one, we have, instead of slash 32, we change it to slash 33. And now this LAN is slash 20 is 34. Now guess what? We can still bring this all the way to 25. We can still go to 192.168.255. And then we've still got all those other class C's in the end. So we've got lots of usable addresses. We were very careful with the addresses. Palm Beach only needs to send one route to Tampa, Texas, and London. Palm Beach is going to receive full routing information from Tampa, which is two routes, the WAN link and the LAN link. And guess what it's going to receive from Texas? The WAN link and the LAN link, and that's it. And guess what it's going to receive from Palm Beach? The WAN link and the LAN link, and nothing more. Does everybody see how we did this? How we took an environment, we subnetted it down, we did something with the addresses in a very simple, elegant way to be sure, to be completely certain that we maximize the use of our address space and minimize the routes in the routing table. Did everybody get that? Because if you guys get this, we're going to turn it into some much more fun routing, or routing, whichever country you're from. Bellwinner, you got it. Derek, you got it. Chapoy, it looks like you're doing great. Alex, it looks like you're 90% there most of the time, which means over time you watch this again, it's going to be completely good for you. Alex, you got it now? I'm thrilled. Okay, so you guys got it. Now let's work through one more networking example. And we're going to do a little routing. Little not really subnetting, but we're going to use all the subnetting together to make this a really good experience for you. You guys are doing great. Very proud of you. I can see that some of you are alive. Type cloud architect to let me know you're there. And if you're willing to help us out with the algorithm and leave a like, we can truly appreciate that. These algorithms track who watches, how long people's watch, whether they like, whether they comment, and all these other kind of things. So if you're willing to help us out, we love it. But, you know, we want you to be honest and true to yourself. So don't ever comment or leave anything that you don't feel strongly about. That's true. Got to be ourselves, and we got to be honest and ethical in everything we do. So let's take this situation now. Now that you guys know networking, or at least some networking, and I'm going to be doing a lot more networking courses. And we're going to do a lot more free, and we're going to have some paid. We're going to do as many as we can. Thank you for letting me know I'm a cloud architect. To let you know, I've been a Cisco certified internet expert for over 20 years. I'm working with another person who's working on his third CCIE, and he and I are creating both a real heavy-duty cloud networking program, and we are also creating a network architect program, and they're going to be released very soon. And they're really about teaching senior networking skills, the kind of skills that a CCIE would have to build a massively wonderful cloud networking career or a network architect career, which is a wonderful career and totally related to the cloud. My network architects go work on the cloud as senior and distinguished architects, literally speaking, with no other background. They're that good. Those that I've trained over the years that are working at AWS and Google and others, I've trained lots of these people working at the Palo Alto cloud, the Dell cloud, the Cisco cloud. So the networking skills are that important. So that's why we're creating so much content around networking. So let's say this is our data center. Now that you guys get the subnetting concept, now let's go to our VPC. This can be AWS, it can be Google, it can be Azure. It doesn't matter. The same thing is going to work. That's why I always say, don't learn a vendor, learn the cloud, learn the right way. So we're going to call this VPC, and guess what? Everybody calls their stuff a VPC too. Doesn't change anything. That's why I'm not going to put AWS or GCP or Azure or Oracle. Who cares? They're just a service provider. All they have is boxes. If you're with Google, it's Compute Engine. If you're with AWS, it's an EC2 instance. It's no different. If you want to manage Cloud DynamoDB with AWS, with Google, it's Cloud Big Table. It's the same. It's like, which brand do you prefer? Kleenex or Puffs? It's the same thing. Nike or Adidas. Don't get bogged down in the cloud. It's silly. It's irrelevant. Get bogged down in the technology. That's all that matters. That's the architecture piece. What is in the best interest of the customer? And whether you go to Walmart, Target, Amazon, Nordstrom to buy it, it's the same thing you're purchasing. So don't worry about it. You guys people often make it too complicated. So let's say we've got a high availability system. Now let's say we want to connect to the cloud. We're going to have a router in your VPC and a router on their cloud. Now, AWS would be crazy enough to convince you that their router is highly available, because it is. completely available, and you don't need two connections to the router because it's available. Here's the problem. Their device is highly available, assuming they don't get hacked or don't have a failure. Their stuff is highly available, but yours is not. So one direct connection to the cloud, not enough. If you put your one direct connection in your router and your router dies, you're broken. And if you have two direct connections to the same part of the cloud, through the same high availability cloud gateway, on one router, and the router dies, guess what? You're down. Totally ridiculous way to do this. So if you want to do it the right way, you're going to do it the way every network architect has done for the last 30 years. You're going to have two, a primary and a secondary across two routers. So it's going to be R1 for you guys in the data center and router 2. Now in the cloud, you can use their HA device in 1AZ, and there's no way on earth I would ever count on that to work in a second place. I would use another HA device and another AZ, and that's how I would set up my connections to the cloud. Now, if we do nothing, when you work with AWS, you run into a challenge. What is the challenge? You must use BGP. So, two equal cost links with BGP. Packets might go from router 1 to the 1AZ, and they may come out they may go to another of they may let's put this. I'm going to make this a little easier. So what happens? Does anybody think this is a good situation? Because it's not. Router 1 sends its data to the area availability zone 1 in your VPC, and then it goes across the AWS environment, and then your data takes a return trip through another availability zone to a different router, to a different through a different service provider. This is a nightmare. This is called out of order packets, because the latency on one connection and the latency on another connection aren't the same, most likely. So if you go out one link and you come back another link, you have a problem. Now, with AWS, what they do is they tell you just to block one link. Now, in 25 years of being a network architect, I've never seen anybody do something so ridiculous. They always load share across their links. You don't pay $20,000 a month for a connection to be there and then leave it idle. You use it. You load share. And you'll do the same thing with AWS. So instead of blocking a link, let's go back to IP addressing and subnetting. We've been playing with subnetting today. We've been having a ball at this. So why does Mike love subnetting so much? So let's say we've got this. Our VPC is using the our data center is using the 10.16 address space. And your VPC is using the 172.16.0.0. /16. Okay, we're there. Now let's say in your VP, actually, let's just say slash. So let's keep it at /16. So let's, for example, say you've got a subnet of 10.0.0.0/24 and a 10.0.0. Let me do this right. 10.0.1.0/24. Let's say these are the two subnets in your VPC. Or I'm sorry, in your data center. Let's not do that. Now let's say you go back to the cloud over here. And over here on the cloud, you've got a subnet of 172.16.0.0/24. You've got a 172.16.1.0/24. Now, let's say you wanted to load share across these links. Well, here's what routers do. Routers always choose the most specific route. Which is more specific? 10.0.0.16, which includes these routes, or 10.0.0.0/24. Guess what? The 10.0.0.0/24 is more specific, and if you don't know how, the more bits a subnet mask, the more specific the route is. So what if you, for example, took this link, the 10.0.1, and you advertised it into BGP on this link, and on the bottom link, you advertise that into BGP. And and you're sending these routes. You got it, Quasi. The /24 is more specific. So you're sending these routes to AWS, Google, Azure, who cares? It's all irrelevant. It's just a store. Pick whichever store you want based upon the services you need. Don't get married to any service provider. You're going to be using them all. There's no such thing in today's world of a single vendor cloud. Well, there's a little, but it's all gone away. A business decision was made that made basically everything hybrid cloud and multi-cloud. So all that's gone. So don't worry about it. Now it's a matter of just, knowing how this stuff works, because you can be working on everybody's cloud as a cloud architect. Now over here, we've got the 1.0. Now look at this. Over the top link, which has the longer subnet mask, the more specific, we've told the VPC, hey, to reach 10.0.0/24, take the top link. We also told your VPC via BGP, hey, best path to 10.0.1.0 was in the bottom link. BGP is bilateral. So we're telling AWS that so AWS can manipulate its routing decisions for us. Now us, AWS, let's play with this. Let's do the following. AWS can influence our traffic signaling by sending a link to the 172.16 on the top link and the 172.16.1 on the bottom link. Why does that do? Now this router says, wow, I know the best way to get to 172.16.0/24 top link because I've got a more specific route. And in the bottom one, we have, guess what? A more specific route. Does this make sense to everybody so far? Because we got a problem in this situation we still have to fix. But does everybody understand this so far? Please let me know in the comment section how we're influencing traffic by sending more specific routes. Let me know that you got that with a yes or a cloud architect or something. And I know there's a massive delay on this link, so work with me. And it could just be that we've been talking networking. So Shapur, you got it. Kwasi, you got it. Derek, you got it. Alex, good. Okay, I'm thrilled. You guys are doing great. Now, what's the problem in this situation? Oh, you guys are all getting it. Wow, now we're doing BGP policy, everyone. So we went from basic networking, talking about the bits and bytes of a subnet, to breaking down into subnet, to route aggregation, to IP addressing for a WAN and a LAN, to now BGP policy in 4 hours. We've done half of a Cisco Certified Network curriculum in 4 hours. You guys are doing great. I mean, this is like a rocket ship pace. You guys are really doing great. So good. Now here's the problem. If the bottom link disappears, this one, the subnets at the top, if the bottom link disappears, these subnets are no longer reachable. I'll show you why in a second. So bear with me, my Mac answers my phone calls. So let's go back into this situation because we're having fun now. And in this situation, we're going to have a party. If this bottom link isn't there, you no longer have a route to the 10.0.1.0 subnet. Does everybody see that? Because the link goes down, the route goes down. So let's put this link back here. Ned, you got it. I see Cloud Architect. I know you got it. So let's put these links back because I want you guys to get it. So what do we do when we need to load share or a traffic engineer? I mean, we could do it via the weight. We could do it via the local preference, AS path. We can play with the med. We can change the IGP origin code. We can do a lot of things. But you guys get it. I'm so happy. You guys, we're getting into CCNP, CCIE level networking in 4 hours. You guys are awesome. Totally blown away. So now, what if on the top link we send this really ugly route to the summary address? And on the bottom link, we send the same summary address. And now, what if from Amazon? Okay, Alex, yes, exactly. We're sending the aggregate route. We send the 172.16.0.0 /16. And we're also sending on the top link this 172.168.0.0/16. Now, in a normal environment, with everything working properly, would you, if the routers only take the most specific path, if you've only got 2 subnets, and we'll talk about what you might actually have to do if you've got multiple subnets to try and block one of the summary route links, but now we're getting into some complexities, so that we probably don't need to worry about for right now, because we only have 2 subnets and they're always going to take the most specific link. So under normal circumstances, traffic for the 10.0/24 is going to take the top link. Traffic for the 10.0/1 is going to take the bottom link. Traffic for the 172.16.0.0/24 is at the top. Traffic for the 172.16.1.0 is for the bottom. Now I ask you all this. Does 172.16.0.0/16, that supernet, include 172.16.0.0 and 172.16.1.0? Everybody, does it? Yes, it does. So what we're doing is we're sending an aggregate or summary link in each direction. Why? If this link on the bottom goes away, gone, 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 gone. Now what exists in the top link? We have the specific route for the one that we wanted to take it, and we now have network layer reachability through the summary route that says, hey, to get to 176 anything, 172.16 anything, take the top link. So now we have full backup. We've got traffic engineering and backup. So I know at the AWS Advanced Networking level, they talk about blocking a link in the CIDR book. I won't talk about what any of those course providers are doing that are there that have never worked in networking. I will totally ignore how they do things because I recommend avoiding those things. But the CIDR publications are very good. We recommend the CIDR books. In fact, we make all free training, our certification training, for free because we couldn't find a course that we actually liked. So we thought we can give you free training courses, and you could buy the CIDR books, which are the books that are official by Amazon, and then you could do well. Same thing for Google. That's why we made our training free, because we wanted you guys to have access to the best. And that means the official manufacturer's documentation, but not necessarily a book is necessarily so good. So we wanted to give you opportunities to learn as well. So a course and a book from the manufacturer at the lowest cost, meaning free from us, 30 bucks from them. You've got a really comprehensive certification planning routine with just those 2. Plus we write books for free, and you can take them. They're all in the link in the description below. So now you guys see what we did. We're just sending the summary route. Why are we sending the summary route? Quite frankly, to provide reachability if and when everything breaks. So now you get it. Now you know how we use subnetting, how we use specific routes for traffic engineering, how we supernet to basically save routes in the routing table, how we traffic engineer by leaking more specific routes. Now there's lots and lots and lots of ways we can traffic engineer in BGP. If anybody wants to learn BGP and you want a BGP day, like a BGP walkthrough day, type BGP day in the section below, and I will find some time to do a couple-hour BGP tutorial, which I happen to think is fun. But it's a pretty in-depth protocol. But I love teaching. Networking is one of the most critical skills for the cloud architect. So if it's going to help you guys, I'm happy to do a free BGP day. I have been informed by my team to let you know that we have a Cloud Architect training program that is approximately 250 hours and takes people from, typically speaking, AWS certified to higher. Although we often work with people that are not AWS certified as well. We don't care. We have to remediate the people that are certified in most cases to teach them the cloud anyway, so certified, non-certified. The way we teach our course is as follows. And most of you guys, while I'm answering this, are actually my students anyway, is on Mondays and Fridays we have 3 hours of live architecture training. And we have a lot of fun. We design systems that are extremely complicated on these days. And while we're doing these days and we're doing our architecture training, in between classes, we have lots of homework assignments and projects to be done, things to build a career plan, things to build presentations, things to help you build a better interview. We do these kind of things. It's important to us to make sure people get hired. We have people do labs on our systems. Labs on our systems, I mean, can include anything from setting up Microsoft Active Directory, for building firewalls, building VPN devices, working with VMware ESXi for virtualization, building containers, building firewalls, VPN concentrators, and yes, all of our students build the cloud because there's no better teacher of the cloud than building one. It's one thing to use a management console and look at some other cloud provider, and it's another thing to build the cloud. So they're kind of the ways we do these things. So I'm seeing some work from Shashruth, from Shapur, from Alonzo, from Balwinder, from Amaranth, from Derek and Adele. You guys want BGP? We will find a day to do BGP. We will talk about the finite state machine. We will talk about prepending autonomous system paths. We will talk about weight, local preference, traffic engineering. We will have a party. We'll start with the beginning of the protocol. Maybe we'll make it a 4 or 6 hour workshop like we did to this. So if you guys like that, we'll do it. I love communicating, networking things. So we'll do some pre-BGP training. Ned, Juwanan, Arun, Adele, Derek, Amrath, you got it. So, to summarize the day, we worked on IP address subnetting. Then we did some supernetting, which is subnetting the opposite direction. We discussed classful IP addresses. We discussed classless IP addresses. We talked about classless interdomain routing and CIDR notation and binary notation. We went from subnetting down to supernetting up, which is route aggregation. When we were done the route aggregation, I had you guys work through several IP addressing problems. And when you're done that, we did some traffic engineering based upon BGP, based upon, guess what? Supernetting. So I hope we tied all these things together. Prior to closing, we've got 10 minutes left. Does anybody have any questions for me? Any questions for me while we close up the day? Nick, you're welcome. Anybody else have any questions for me? You know, whether any kind of networking for cloud computing, AWS networking, what is CIDR, that kind of thing? Okay, well, it's gotten pretty quiet. You're welcome, Balwinder, and thank you so much. Alex, thank you. Derek, so happy to help. You guys really did great. You know, Shapur, it's a good question. When it comes to AWS, they do much more behavioral interviews than actual technical interviews, like a lot more. But I would assume that you could get asked a subnetting question on any interview, anywhere, anytime. Thanks, Kwasi. Amaran, thank you. Alonzo, really appreciate everything you do for us, as well as your kind words. Were there any subnetting problems in GCP? I took the Google Professional Cloud Architect a long time ago. I only spent 2 days studying for it, by basically just because I knew the cloud. I found it to be an extremely easy exam, Arun, and I think there was one subnetting question on there. Shoshrath, if your CIDR block is overlapping, meaning they're not overlapping IP addresses. So if you're using a 10.0.0/16 in the data center, and a 10.0.0/16 in the cloud. But in the data center, using 10.0.1.0 and 10.0.2.0 and 10.0.3.0 and 10.0.4.0. And in the cloud, you're using 10.0.200.0 and 10.0.201.0 and 10.203.0. There's no overlap. The problem is you can't summarize your routes, which means you aren't going to be able to traffic engineer your traffic very well, which basically means you're handicapped. So will it work? Yes. Will it work optimally? The answer is no. And that's the problem, just to let you guys know. When you have non-networking people that are doing IP addressing and configurations, if they don't know this really well, the addressing scheme gets messed up. If the addressing scheme gets messed up, the routing is messed up. And if the routing is messed up, you can't influence or engineer your traffic anywhere, and everything falls apart. Carlito Way, what a great way. What a neat term. I haven't seen that movie in ages, but I do remember loving it. Although they could have used some medical consultants in the beginning of that movie when they had some IVs taped down the wrong direction and things like that. But otherwise, it was a great movie. Okay, any last minute questions for me? Any more? Well, I'm going to kick it off, with the word cloud architect in the box. If you guys all want to type cloud architect, we know you're still alive. And I'm going to say that we're going to close this session out after that, unless any of you guys ask any more questions. And if you've got questions you want to know, reach out to us. And thank you all. It's been a wonderful day. I'm going to stay here. I want to make sure no other questions pop up in the next minute or two. And then after that, we'll close it out. Thank you so much, John Doe. Adele and Arun, thank you. Ian, thank you. Bellwinder, thank you for letting me know you're there. Shashrath, great job. John Doe, great job. Nick, love, awesome, thank you. Arun, thank you. Chaitin, thank you. Chintan, thank you. And Chintan, that message you sent me on Saturday, you have no idea what it meant to me. Shapur, thank you. And Ian, the cat's actually doing great. Thank you. Amaranth, Alonzo, awesome. Although I think the cat thinks she's the queen of the house and that I'm just here to serve her, which is probably the case, but whatever. She's my cat. Thanks, Ian. Thank you all. It's been a wonderful time to see you. For my students, I'll see you all on Friday, and we'll have a really interesting kind of architectural discussion. It's going to be a little different than we usually do, but it'll be fun. So, welcome. Take care, everyone.